Hello there, and welcome to Life Beyond Seen, where curiosity settles in for the evening, science speaks a little more softly, and the world becomes just strange enough to keep the mind interested, while the rest of you begins to loosen its grip on the day. Tonight, we are heading out over open water, far beyond the shoreline, past the neat little edges of maps and holiday postcards, into a place that has always been very good at hiding large, unsettling things. Our gentle subject for this evening is a creature that somehow manages to be both famous and hard to picture properly at the same time. You know the name. Nearly everyone does. Megalodon. A shark so enormous that even modern sharks begin to look less like apex predators and more like enthusiastic interns with sharp teeth. But we're not only talking about the ancient animal itself, we're stepping into a much stranger possibility. What if Megalodon were still alive today? Not in a grainy internet clip with dramatic music and several red circles pointing at a wave. Not in the way a friend leans in at a party and says, "I'm just saying, the ocean is big." Not as a rumour, a movie monster, or a suspiciously large shadow edited into a documentary thumbnail. What if it were really here, still moving somewhere beneath the modern sea, sharing the planet with cargo ships, oil tankers, fishing boats, submarines, beachgoers, scuba divers, and all the rest of us who have become quite used to behaving as though the top of the ocean belongs mostly to humans. That is an interesting habit when you think about it. We stand at the edge of the water and speak of the sea as though it were a place we understand. We give parts of it names. We chart it. We fish it. We cross it. We drop cables through it and build machines to scan it and send cameras down into it. And yet the ocean remains one of the few places on Earth that can still make modern people feel ancient in the head. We are very clever on land. In deep water, we become a little less confident, a little more respectful, a little more aware that the world was not built with our comfort in mind. Add a shark the size of a moving truck, and respect becomes something closer to a lifestyle choice. So tonight, as the day quiets down and your thoughts begin to spread out a bit, let us consider that possibility carefully. Let us take it seriously, but not too seriously. No need to panic. No need to start eyeing your bathtub with suspicion. We are not here to create a crisis. We are here to look at the idea from every angle and see what kind of world it gives us. A world where Megalodon never fully vanished. A world where somewhere under all that dark water and shifting light, a giant predator still patrols the deep roots of the sea. Before we drift any farther into it, I would love for you to notice where you are right now. Not in some grand philosophical sense. Just literally, are you in bed already? Curled into a chair, resting on a sofa, sitting in a dim kitchen with one small light still on for no very good reason, except that it feels nicer that way. Perhaps you are listening with rain against the window, or with summer air moving in through a crack in the room, or with a fan humming gently somewhere nearby, doing its best impression of a small aircraft preparing for takeoff. Wherever you happen to be, and whatever hour your little corner of the world is keeping, it feels strangely fitting to spend a while thinking about a creature from another age, in the quiet company of the present. And where are you listening from tonight? A coastal city, a landlocked town, somewhere with gulls, somewhere with buses, somewhere so far from the sea that the nearest shark is probably printed on a cereal box. There is always something enjoyable about that, talking about oceans with people scattered across different places, each one carrying a different picture of the sea in their mind. For some, the ocean means holidays, warmth, salt on the skin, and the sound of waves just beyond a hotel balcony. For others, it means ferry crossings, grey water, working harbours, foghorns, and the sort of wind that gets into your sleeves and asks you to reconsider your choices. For some people, the ocean is something visited. For others, it is background. For others still, it is mostly a concept. A giant blue fact on a globe. If this evening's journey turns out to be a soothing one for you, or simply a pleasant way to let your thoughts slow down while we talk about very large teeth in a calm and civilized manner, do consider giving the video a like, and perhaps subscribing as well. It helps this quiet little corner of science and sleep find more people who enjoy winding down with odd questions and even odder answers. There is something encouraging about knowing that somewhere out there, other people are also spending their evenings listening to long, gentle explanations about extinct predators and the consequences of bringing them into the modern world. It says good things about humanity, or at the very least interesting things. Now, Megalodon has a special talent for making the imagination behave badly. The name alone tends to produce immediate results. Massive jaws, endless rows of teeth, a dark shape below the surface, sudden music, usually in a minor key. It is one of those prehistoric animals that arrives in the mind already carrying a suitcase full of exaggeration. Dinosaurs have this problem too, so do giant squids. Human beings are extremely fond of taking a real thing, adding 20% more size, 60% more attitude and a soundtrack, and then acting surprised when it becomes difficult to sort the biology from the drama. But underneath all that spectacle, there is a genuinely fascinating animal. A real creature that once lived in the oceans of Earth, not as a fantasy but as an apex predator shaped by evolution, environment, hunger, competition, and opportunity. It did not exist to frighten documentary viewers. It existed because for a time, the seas could support it. The food was there, the climate was right, the balance worked, until eventually it did not. That much belongs to the known world of paleontology and marine science. The more playful question, the one we are following tonight, begins where the fossil record leaves off and imagination quietly pulls up a chair. What if that ending never happened? What if, through some twist of survival, some favourable pocket of habitat, some long stretch of ecological luck, Megalodon remained part of Earth's living ocean? Not necessarily common, not necessarily easy to find, but present, real, breathing, feeding, growing, reproducing, leaving scars on whales and silence in places where other animals have learned to move carefully. Immediately the mind starts reaching for numbers, because that is what it does when frightened politely. How big? How many? Where? Could one overturn a boat? Could radar find it? Would we know already? Would governments hide it? Would surfers simply give up and take up chess? It is tempting to sprint straight toward the most dramatic possibilities, but the more interesting route is a slower one. If Megalodon were alive today, it would not exist in isolation from the rest of the world. It would exist inside a modern system, and that means everything around it would matter. Ocean temperatures, prey availability, shipping routes, fishing pressure, whale populations, human technology, coastal development, pollution, noise, deep-sea monitoring, conservation law, news media, tourism, insurance paperwork, which, when you think about it, is one of the least glamorous but most certain signs that humans have encountered something enormous and inconvenient. Because modern life has a habit of making even the grandest things strangely administrative. A giant prehistoric shark can survive the ages, but somewhere eventually there will still be a meeting about liability. Someone will produce a chart. Someone else will say, we need a framework. Another person will say, can we call it an incident event rather than a catastrophic marine encounter? This is one of the peculiar strengths of our species. We're capable of being awestruck and bureaucratic at the same time. Still, before we get to the shipping lanes and the science teams and the anxious beach towns, it helps to pause for a moment and really sit with the basic idea of the animal, not the cartoon, not the poster, not the cinematic version that rises vertically out of the sea with impossible determination and a suspicious awareness of camera angles. Just the animal itself, a shark of extraordinary size, built for power, moving through water with the efficiency that sharks have been refining for a very long time indeed. Sharks are old in the broadest evolutionary sense. They belong to a lineage that predates dinosaurs, which is one of those facts that sounds less like science and more like a threat whispered by nature. They have been solving the problem of being a successful marine predator for hundreds of millions of years. Sleek body, sensitive detection systems, efficient movement, replaceable teeth, a general refusal to overcomplicate things. Megalodon was not some bizarre experiment with fins. It was in many ways a shark taken to an extreme, a design stretched upward in scale until it became one of the most formidable predators the oceans have ever carried. That is part of what makes the question so gripping. We are not asking what would happen if a dragon returned, or a sea serpent from myth, or some impossible hybrid dreamed up by a studio executive who believes every problem can be improved with more spikes. We're asking about a plausible animal, an extinct one, yes, but not an imaginary one. A creature that obeyed biology, a creature that hunted, migrated, fed young, avoided injury when it could, and lived in an ecosystem full of real constraints. And that makes the thought experiment much richer, because if it were alive now, it would have to continue obeying those same rules. It would need enough food, it would need space, it would need reproductive success, it would need juveniles that could survive long enough to become adults. It would need seas capable of supporting an animal of such scale in a world humans have already changed in major ways. That makes the question less like a monster story, and more like an ecological puzzle, and that is where it becomes truly interesting. Fear gets people in the door, ecology keeps them there. There is also something revealing about why humans keep returning to this animal again and again. Megalodon is not just large. Plenty of prehistoric animals were large. It is not just dangerous. Plenty of predators were dangerous. There is something specific about a giant shark that gets under the skin of the imagination. Perhaps it is because the ocean already limits us. We do not move through it naturally. We skim across the top, dip into it briefly, and build equipment to tolerate it. Below a certain depth, the sea reminds us very quickly that this is not our kingdom. So when you place a giant predator there, one mostly unseen until it chooses otherwise, the mind begins filling in every dark space beneath the waves with possibility. And yet, for all that unease, there is also a strange attraction. People are not only frightened by great predators, they are drawn to them. We travel to see whales breach, even though a whale is large enough to make a person feel like a lost button. We admire lions, tigers, bears, crocodiles, wolves, eagles and orcas, not because they are safe, but because they are impressive in a way humans understand instinctively. Strength, skill, confidence, and the ability to survive on terms not set by us. A living megalodon would represent that feeling on a scale difficult to ignore. Terrifying, yes, but also awe-inspiring in the most literal sense. It would restore a certain bigness to the world. That may be one reason the idea lingers. Modern life can feel very mapped, very measured. We track storms from phones, we photograph the seafloor, we tag sharks, we watch migrations unfold as points on screens. We're used to knowing, or at least feeling close to knowing. The possibility of a giant predator still living beyond routine detection offers something many people secretly miss, which is the sense that the world is not finished introducing itself. There are still things large enough, old enough, and hidden enough to make certainty wobble. Of course, if Megalodon really were alive today, that romantic feeling would last right up until someone's expensive yacht developed a sudden respect for marine biology. Wonder has limits. It tends to shrink in direct proportion to tooth size. Even so, it is important not to reduce the entire conversation to human panic. The ocean is not only a backdrop for our fears, it is a living system, and any animal of Megalodon scale would matter far beyond its interactions with us. Its presence would ripple through food webs, it would shape prey behaviour, it would compete with other major predators, it would alter where some animals fed, how others migrated, perhaps even where certain species could safely gather in large numbers. One top predator does not merely occupy space, it changes the behaviour of everything around it. That is true even in systems we understand well. Wolves change deer movement, sharks change seal behaviour. Orcas can alter the distribution of prey across huge areas. Predators do not just remove animals from an ecosystem, they reorganize it, sometimes subtly, sometimes dramatically. So when we imagine Megalodon surviving into the present day, we are really imagining an ocean that has been shaped for millions of additional years by the continued presence of one of its most powerful hunters. Whales might live differently. Other sharks might occupy different niches. Some coastlines might feel calmer than others for reasons no one on shore ever fully explains. The sea itself would carry a different pattern. There is another side to all this that deserves attention as well. If Megalodon lived today, it would not only threaten, it would also be threatened. That sounds almost unfair given the size of the creature, but modern humans have a remarkable ability to endanger animals of any size whatsoever. We overfish, we pollute, we fill oceans with noise, we entangle marine life in gear, we alter climate systems, we acidify water, we reduce prey populations, we move relentlessly into habitats that once had the decency to keep a little distance from us. A living Megalodon, however powerful, would still have to survive a planet already reshaped by humans. That changes the tone of the question in an important way. It stops being only, would we be safe from it, and becomes also, would it be safe from us? It is a less dramatic question on the surface, but often the more important one. Giant predators have a hard time in human-dominated worlds. They require large territories, stable food sources, and enough tolerance from our species to exist without being hunted into legend. Many of them have learned, to their disadvantage, that humans are often deeply interested in preserving animals in theory, and considerably less relaxed about doing so in the immediate vicinity of boats, livestock, beaches, or profit. So as we move into this idea together, it helps to keep both responses in view. The old instinctive one, fear, and the newer, perhaps wiser one, responsibility. A surviving Megalodon would be one of the most astonishing animals on Earth. It would also be one of the most complicated. The discovery would change science overnight, and journalism and tourism and coastal policy, and quite possibly the number of people willing to dangle their feet off small boats for recreational purposes. But it would also place us in a relationship with something ancient and powerful that did not evolve for our convenience. And perhaps that is part of why the question stays compelling. It asks us to imagine a world where the sea retained one more piece of its old authority, a world not fully tamed, a world where the top of the water remained familiar enough, but the depths carried a fact so large it would reorganize our confidence. For now though, before the headlines begin, and before we start tracing possible habitats across the globe, it is worth getting properly acquainted with the animal itself, because the next step is not to panic about where it might be. The next step is to understand what it was, what kind of shark it likely would be if it still lived among us, and why its very size would shape everything about how it moved through the modern ocean. To do that, we need to get a proper sense of the animal itself, because Megalodon tends to arrive in conversation already wrapped in exaggeration. People hear the name and immediately picture a giant mouth, a black fin, and somebody in a research vessel regretting their career choices. Fair enough. It is not an animal that encourages modest mental images. But if we are going to imagine it alive in the modern world, then it helps to set aside the poster version for a while and meet the actual creature as carefully as we can. Megalodon, usually referred to by the scientific name Otodus megalodon, was not simply a big shark. It was a shark operating at the upper edge of what the marine environment could support for a macropredator, and that distinction matters. Plenty of sharks are impressive. The great white is impressive. The tiger shark is impressive. The Greenland shark is impressive in the specific way that something becomes impressive when it looks half asleep and may still outlast your family line. But Megalodon belonged to another scale altogether. When paleontologists estimate its size, the numbers vary depending on the reconstruction, the measurements used, and the degree of caution involved. But the general picture is consistent. This was an animal that may have reached around 15 to 20 metres in length, with some estimates pushing the largest individuals a bit beyond that. Even the conservative end is enough to make a great white look like it turned up slightly underdressed for the occasion. That difference in size is difficult to feel properly, because the human brain is unreliable around very large dimensions. It hears 18 metres and nods as though that means something. It does not mean something until you compare it to objects you already know. A large city bus is around that sort of length. Some smaller boats are shorter. Put a great white beside a megalodon, and the great white stops looking like the undisputed terror of the seas and starts looking like a serious but manageable employee at a much larger company. This is why scale changes the emotional temperature of the whole subject. We're not dealing with a shark that is merely dangerous. We're dealing with a shark so large that its basic existence begins to alter the tone of the water around it. And yet, remarkably, we do not know Megalodon from complete fossil skeletons laid out neatly in museum drawers. Sharks, as you may know, are not generous with their remains. Their skeletons are made mostly of cartilage rather than bone, and cartilage does not fossilise nearly as obligingly as paleontologists might wish. If sharks had the courtesy to leave behind full skeletons every time they died, several branches of marine paleontology would be noticeably less stressful. Instead, what Megalodon left us in abundance were teeth. Very large teeth. Teeth so large and so distinctive that they became the calling card of the species long before the rest of the animal could be reconstructed with any confidence. This is one of those pleasing cases where the fossil record and popular imagination shake hands. If you're going to be known mostly by one body part, giant triangular serrated teeth are admittedly strong branding. Megalodon teeth can measure more than 15 centimetres in slant height, sometimes even more in exceptional specimens. Hold one in your hand and you're not left wondering whether it belonged to a modest fish with self-esteem issues. You're holding evidence of an animal designed to bite through dense flesh and bone. The teeth are broad, robust and serrated, more like industrial cutting tools than decorative accessories. They tell us not only that the shark was large, but that it was feeding on substantial prey. You do not evolve a mouthful of steak knives the size of your palm because your lifestyle revolves around nibbling politely. And this is where the story gets especially interesting. Megalodon was not simply an overgrown version of any shark alive today. It was likely a hunter of large marine mammals, especially whales, along with other sizable prey. Fossil whale bones have been found with bite marks that match Megalodon teeth, and these marks suggest active predation or at the very least highly enthusiastic scavenging. Either way, the animal was interacting with prey on a scale that puts it firmly at the top of the food web. It was not drifting around hoping for opportunities, it was built to create them. When scientists try to reconstruct the body of Megalodon, they rely on comparisons with living sharks and on the proportions implied by the fossil evidence. For a long time, popular reconstructions leaned heavily on the great white shark, because the teeth look broadly similar and because the great white already occupies a familiar place in our imagination as the classic large predatory shark. That made sense as a starting point, but it also encouraged a rather simple picture. Imagine a great white, then continue enlarging it until everyone nearby begins writing hasty letters home. More recent work has suggested that the body shape may have differed in important ways, perhaps resembling a more streamlined and powerful build suited to long-distance cruising and high-efficiency movement in open water. In other words, Megalodon may not have been just a giant great white. It may have been its own thing entirely, optimized for a life at a scale modern sharks no longer represent. This matters because shape tells you about lifestyle. A bulky ambush predator behaves differently from a sleek, wide-ranging cruiser. An animal that patrols vast ocean distances has different energy needs, hunting habits, and territorial logic than one that lingers near coasts waiting for the right moment. So when we say Megalodon was the largest shark to ever live, that phrase does not just describe size, it implies a whole biological strategy. Enormous body, huge caloric demand, powerful bite, Long movement across productive marine environments. It implies an animal that could not afford to be inefficient. Now, the bite itself deserves a moment, because few extinct animals have had their bite discussed with such persistent enthusiasm. Estimates of Megalodon's bite force vary, but the upper range enters frankly unreasonable territory. We are talking tens of thousands of pounds of force, enough to crush bone and grip large prey with horrifying confidence. It is one thing for a predator to wound. It is another for it to remove options. A bite at that scale would have made Megalodon one of the most formidable vertebrate predators in Earth's history. Not because it was aggressive in some cartoonish sense, but because physics was on its side. Size changes everything. Muscle mass changes everything. Leverage changes everything. At a certain point, the ocean stops asking whether you can dominate a prey animal and starts asking what exactly is left once you do. Still, even a predator that large begins life small, and that is another part of Megalodon's biology that deserves attention. Fossil evidence suggests that Megalodon pups were already quite large at birth, perhaps around 2 meters or more, which is an astonishing thing to say calmly. Imagine entering the world already long enough to concern lifeguards. This implies a reproductive strategy involving a significant maternal investment, likely with relatively few but very well developed offspring. Some researchers have suggested a form of intrauterine cannibalism, in which developing embryos consume unfertilized eggs or possibly even smaller siblings, as seen in some sharks today. Nature, as usual, remains committed to making human parenting seem somewhat simpler by comparison. Large birth size also suggests that juveniles needed nursery areas where they could grow with reduced risk from even larger predators. Coastal environments may have served that role, providing productive shallower waters rich in food. That makes ecological sense. A young Megalodon, although already formidable by most standards, would still have benefited from a place where it was not immediately competing with adults, the size of mobile architecture. This detail becomes important later when we imagine the species alive today, because nursery grounds are often the weak point in the survival of large marine predators. It is one thing for an adult giant to roam the open sea. It is another for the young to survive in a modern ocean full of nets, vessel traffic, degraded coastlines, and humans who keep building things precisely where wildlife once relied on quiet. The time period in which Megalodon lived also helps explain how it became possible at all. This shark inhabited Earth's oceans during the Miocene and Pliocene, roughly from around 23 million years ago until about 3.6 million years ago, though exact dates are refined as evidence improves. Those were oceans with abundant marine mammals, different climates, and ecological conditions favourable to very large predators. Whale diversity was growing. Many marine food webs were rich enough to support extreme specialisation and extreme size. Megalodon did not appear out of nowhere like a punchline. It was the product of an environment that could feed it, and that is always the first condition for gigantism. Nothing grows that large on optimism alone. It is easy to picture Megalodon as a terror with fins, but like all successful predators, it was probably efficient before it was dramatic. Efficiency is what keeps an animal alive. A wasted attack costs energy. A bad injury can be fatal. A giant shark does not survive by roaring at things and hoping for the best. It survives by being very good at what it does. That likely meant carefully selected prey, calculated strikes, and movement patterns shaped by migrations and ocean productivity. Large whales would have been obvious targets, especially younger or weaker individuals. Marine mammals carry dense packages of fat and protein, which is exactly the sort of thing an enormous predator would find economically sensible. That may sound cold, but ecology is basically the study of practical arrangements under pressure. There is evidence that Megalodon may have targeted specific body regions on prey, such as the chest or fins, to disable movement and cause fatal damage. Again, this points to strategy rather than chaos. Predators of that scale do not remain dominant by being reckless. They remain dominant by being very selective with force. In that sense, Megalodon may have had more in common with modern orcas than with the movie version of a shark as a mindless bite machine. Large predators often appear brutal to us, but what they are really doing is solving problems with evolved precision. If the solution happens to involve several hundred serrated teeth, that is unfortunate for the prey, but not evidence of bad planning. Now, because the great white shark looms so large in popular culture, people often wonder how Megalodon compares. The simplest answer is that the great white is the nearest familiar reference point, but the difference in scale makes the comparison almost unfair. A large great white might reach 6 meters, perhaps a bit more in exceptional cases. That is enough to command respect. Megalodon was in another category. The difference between them is not like the difference between a medium dog and a large dog. It is more like the difference between a wolf and a small delivery van equipped with teeth. This is not an insult to great whites. It is simply that Megalodon was operating in a size bracket where ordinary comparisons begin to fail. The size of the jaws alone gives you some sense of the matter. Reconstructions suggest a gape wide enough to engulf major portions of large prey in one bite. A human standing inside a reconstructed Megalodon jaw tends to look less like a visitor to a museum, and more like someone who has made a series of regrettable choices. That visual has done wonders for public engagement with paleontology, though perhaps not for general comfort around oceans. Still, it makes the point. We're dealing with an animal that forces scale upon the imagination whether the imagination is ready or not. And yet, despite all this talk of size and bite force and whale hunting, Megalodon was still a shark, which means it belonged to a successful template honed by evolutionary time. Streamlined form, powerful tail propulsion, electroreception to detect prey, acute senses adapted to water movement and chemistry, a body plan suited to being exactly where it needed to be at the decisive moment. We should be careful not to think of it as a sea monster first and a shark second. It was a shark first. The monstrosity is simply what happens when shark design is scaled upward into an ecological role few animals can challenge. There's also a common temptation to imagine any giant predator as unstoppable, but real animals are constrained by biology in ways monsters are not. Megalodon needed a functioning metabolism. It needed enough prey in the right places, it needed healthy young, it needed conditions that justified its bulk. Larger animals gain certain advantages, but they also inherit larger demands. A giant predator does not live lightly on the land or in the sea. It consumes more. It requires more territory or more productive habitats. It becomes more vulnerable to shifts in climate and prey abundance. In that sense, Megalodon's greatness was inseparable from its dependence. The larger the hunter, the more the world must cooperate. This may also help explain why it eventually disappeared. Scientists propose several contributing factors: cooling oceans, changes in sea levels, shifts in prey distribution, competition from emerging predators such as early great whites and possibly orcas, and the decline of suitable nursery habitats. No single explanation neatly does all the work, which is often the case in extinction. Life does not usually end because one door closes, it ends because several close at once. A giant predator dependent on rich marine mammal populations, warm nursery waters, and stable migratory systems would have been vulnerable when those systems changed. The animal's size, once its great advantage, may have become one of its burdens. That makes its legacy a little different from that of many extinct animals. Megalodon did not vanish because it was primitive or poorly designed. On the contrary, it was almost too well designed for a world that no longer stayed suitable. It was specialised for abundance, for particular prey, for certain ocean structures. When the term shifted, the giant could not shift quickly enough with them. There is something sobering in that. The biggest shark ever to live was not defeated in single combat by a plucky rival. It was outlasted by ecological change, which is the less cinematic but far more realistic ending. Even so, the fossil record it left behind is enough to keep its image vivid. Teeth found across many parts of the world tell us it had an enormous geographic range. This was not a local oddity tucked away in one peculiar basin. It was a widespread top predator in the global ocean. That geographical reach reinforces the picture of a highly mobile animal moving through productive marine corridors and exploiting rich prey distributions. It also means that if Megalodon were somehow alive today, its presence would not likely be confined to one spooky trench and one secret island where everyone in the research team has very mixed feelings. It would be a major oceanic fact, broad in range and significant in impact. And perhaps that is the most important thing to understand at this stage. Megalodon was not simply the biggest shark, it was a different order of marine predator, one that combined the core strengths of sharks with a scale rarely seen among carnivorous animals. It sat at the intersection of size, power, and ecological opportunity. It was the product of oceans rich enough to sustain it and stable enough for a time to allow it to dominate. That is why the animal continues to hold attention so easily. It does not feel like an exaggeration created by us. It feels like reality briefly got carried away. Once you begin to see it clearly in those terms, the next question follows naturally. If a shark like that somehow never disappeared, then the real challenge would not only be imagining its size, the real challenge would be explaining how an animal with such enormous needs could have made it all the way into our century, through changing climates, shifting prey, noisy industrial oceans, and an increasingly intrusive species that likes to assume it notices everything important. That is where the thought experiment becomes more demanding, because keeping Megalodon alive in the modern world is not as simple as deciding it managed to avoid extinction by being large and unpleasant to argue with. Size alone does not protect a species across millions of years. In fact, very often it does the opposite. Large animals are expensive. Large predators are even more expensive. A shark of that scale would need an extraordinary amount of food, suitable breeding grounds, enough surviving young, a stable ecological role, and an ocean that still offered the right temperatures and prey in the right places. If Megalodon never vanished, then something about Earth's changing seas would have had to continue working in its favour, or at least fail to work strongly enough against it. So the first thing to understand is that survival into the present would not likely mean Megalodon stayed exactly the same in every respect from the Miocene to now. That is not usually how long-term survival works. Species persist by adapting, shifting range, changing diet, altering behaviour, or becoming more flexible than their fossil-era versions. The Megalodon alive today, if such an animal existed, would almost certainly be a descendant population shaped by millions of additional years of selection. It might still be recognisably Megalodon. It might still be enormous, still equipped with crushing teeth, and still fully capable of ruining the calm tone of any ocean expedition. But it would also have to be a survivor, which means it would need traits that favoured persistence under pressure. One major pressure would be climate. The world Megalodon originally inhabited was not the same as ours. Ocean temperatures have shifted, currents have shifted, coastal geography has shifted, entire marine communities have changed. If Megalodon survived all that, then it likely did so by tracking favourable habitats, rather than stubbornly staying put out of loyalty to historical waters. Modern descendants may have retreated into warmer belts, concentrating in tropical and subtropical zones, where metabolic costs were manageable and where large prey remained available. That alone would already make survival more plausible. A species does not need every ocean. It needs enough of the right ocean. Temperature would matter for another reason as well. There has long been debate over how warm-bodied Megalodon may have been compared with modern sharks. Some studies suggest it may have had some level of elevated body temperature, allowing for powerful swimming and active predation. If that were true, it might have had advantages in movement and hunting, but it would also face high energetic demands. To survive into the present, that physiology could not be too extravagant. The modern form would likely need a workable compromise, active enough to remain a top predator, efficient enough to survive when conditions were less generous than they had once been. In evolutionary terms, the survivors are often not the biggest or boldest. They are the ones whose expenses remain just low enough to make tomorrow possible. Food, of course, would be the central issue. A giant shark cannot continue as a giant shark on good intentions and the occasional unfortunate seal. If Megalodon lived today, it would need a prey base large enough and reliable enough to support adult individuals over long lives. The obvious candidates are whales, especially medium-sized baleen whales, large pinnipeds in some regions, perhaps large fish and marine mammals depending on local conditions. But here the question sharpens. Could modern oceans really support such a predator in meaningful numbers? The answer is that they might, though likely not in the dramatic abundance people imagine. Whale populations today are still recovering from industrial whaling in many parts of the world. Some species remain depleted, others have rebounded better. If Megalodon had survived continuously, the history of whales might look somewhat different, because they would have spent the last few million years under continued pressure from a very large shark. That could alter migration routes, calving areas, body sizes, and even species composition over evolutionary time. It might also mean that whale populations which exist today would be the ones that proved best at living alongside such a predator, not simply the ones we happen to know from our current timeline. This is important because it suggests the modern ocean in a Megalodon world would not just be our ocean plus one extra shark. It would be an ocean already adjusted to its presence. That is much more realistic. Prey species would not behave carelessly in waters where a giant predator was part of the long-term system. Whale mothers might calve in different locations. Some species might avoid certain migration corridors. Grouping behaviours could be tighter in risky regions. Other predators, such as orcas, may have developed different movement patterns to reduce competition or conflict. The sea would carry the memory of Megalodon in the behaviour of everything else. Even so, the population size of surviving Megalodons would probably have to be quite small compared with people's cinematic expectations. You do not get thousands of bus-sized apex predators roaming every ocean basin, unless your food web is performing miracles. Far more plausible is a sparse, widely distributed population, concentrated in specific productive zones, with huge ranges and low encounter rates. That would help explain how the species might remain difficult to observe consistently, even in the age of satellites and sonar. Oceans are vast, truly vast. Humans are very impressed with our monitoring systems, but much of the sea remains patchily observed, especially in deeper offshore regions. A rare, wide-ranging predator could avoid routine detection far more easily than a coastal animal frequently crossing our favourite beaches. Reproduction would be another critical hurdle. Large predators reproduce slowly, and slow reproduction is both their strategy and their weakness. If Megalodon survived, it would need nursery areas protected enough to allow juveniles to reach maturity. That means warm, shallower waters with abundant prey, relatively low competition from adults, and a reasonable chance of escaping human disruption. In today's world, that is a difficult requirement. Coastal habitats are among the most heavily altered places on Earth. Estuaries are developed, shelf waters are fished hard. Boat traffic is constant in many regions. Pollution accumulates, noise travels. If Megalodon still used ancient-style coastal nurseries, its young would be under continuous threat. So perhaps the species would have had to alter its early life strategy. One possibility is that the modern descendant uses offshore nursery zones rather than nearshore ones, giving birth around island arcs, seamount regions, or warm pelagic areas with enough food and less human interference. Juveniles might grow up in remote stretches of ocean where prey is modest but dependable, and where adults pass through only occasionally. Another possibility is that birth size increased even more over time, producing fewer but more developed pups already capable of handling a wider range of environments. That would reduce some nursery dependence, though at the cost of very low reproductive output. Again, survival becomes a balance of trade-offs rather than a matter of simply remaining fearsome. Behavioural flexibility would probably be essential. A modern Megalodon that survived unchanged in temperament and routine, cruising obvious coastlines and attacking anything large enough to cast a shadow, would not stay unnoticed, and likely would not stay alive. Humans are not especially tolerant of repeated large-scale surprises. Any surviving lineage would need habits that incidentally reduce conflict with us. It might spend most of its time well offshore. It might favour deep transition zones where continental shelves drop away. It might hunt along whale routes far from recreational waters. It might rise toward the surface mostly at night or in poor visibility, using depth and distance as a shield against detection. In other words, its survival may depend not on theatrical encounters, but on disciplined avoidance. That alone helps the scenario make more sense. The popular image of Megalodon surviving usually involves constant sightings somehow ignored by authorities, which is absurd. But a rare giant shark living mostly beyond ordinary traffic, crossing immense ranges, surfacing briefly, feeding infrequently but efficiently, and spending long stretches in remote pelagic regions is far more plausible. People underestimate how much can happen in the open ocean without an audience. A fishing boat sees only its own patch of water. A cargo ship sees the route ahead. A satellite sees certain things under certain conditions. There is no single all-seeing human eye resting comfortably above the sea. Dietary flexibility could also be part of the answer. The fossil Megalodon appears to have specialised heavily in marine mammals, but specialisation becomes dangerous when environments change. A surviving lineage may have broadened its prey base somewhat, not enough to abandon large prey entirely, but enough to endure leaner periods. That could include scavenging more often than people imagine, taking advantage of whale carcasses, large fish schools, pinnipeds in some regions, or weakened animals during migration bottlenecks. Modern sharks already show a degree of opportunism, and there is no reason a giant one would refuse practical meals out of pride. Nature does not award points for maintaining a strict personal brand. There is another way survival could become more plausible, and that is through reduced size. This tends to disappoint people because everyone wants the full nightmare package, but evolution is not obligated to preserve our favourite dramatic proportions. If Megalodon persisted into the present, it might not average at the largest estimates associated with its ancient peak. A somewhat smaller modern descendant, still enormous by any rational standard but not quite at the outer limits of the fossil giant, would be much easier to support ecologically. A lineage averaging, say, 12 to 15 metres rather than pushing constantly toward the far upper end would still be immense, still biologically recognisable as Megalodon, and far more realistic in terms of energy budgets. In evolutionary history, dwarfing or resizing in response to environmental pressure is not uncommon. The public might object. The shark would not care. Competition would also shape its survival. Modern oceans already contain major predators. Orcas are intelligent, social, and capable of taking down large prey with astonishing efficiency. Great whites dominate certain niches. Large tiger sharks, sleeper sharks, sperm whales, and other top marine animals all occupy pieces of the predator landscape. A surviving megalodon would need to fit among them, not in fantasy isolation. This means its niche would have to be specific enough to justify its existence. Perhaps it specialises in larger migratory prey farther offshore than great whites usually target. Perhaps adults dominate deep pelagic intercept routes where whales cross from feeding zones to breeding grounds. Perhaps they are seasonal hunters, concentrated around times and places of prey abundance. The more specialised and geographically selective the species, the easier it becomes to imagine long-term coexistence. A useful comparison here is with very large terrestrial predators and herbivores. Animals with huge body size do not blanket every landscape evenly. They follow productivity. They cluster around what can support them. They vanish from places that cannot. The same would be true in the sea. A living megalodon would likely be tied to hotspots, regions where currents bring nutrients, where prey congregates, where migratory corridors narrow, where the odds of a high-value meal are worth the energy spent arriving. That may mean parts of the North Atlantic in certain seasons, sections of the Indian Ocean, productive belts in the Pacific, or deep edges near island chains. It would not mean random appearance in every patch of water, where someone drops a camera and hopes for a viral moment. Human interaction complicates all of this further, but not necessarily fatally for the species. People often assume we would certainly have found such an animal by now, but detection depends on encounter rate, evidence quality, and interpretation. A rare ocean predator could leave behind ambiguous clues for a surprisingly long time. Whale carcasses with unusual bite marks might be blamed on known predators or scavengers. Sonar anomalies might remain anomalies. Eyewitness reports from sailors are notoriously filtered through fatigue, weather, fear, and a long maritime tradition of saying things that sound unbelievable even when perfectly true. Even a tooth found today might first be assumed to be fossil rather than fresh, unless context made otherwise impossible. Discovery requires not only evidence, but evidence arriving in a way people are prepared to recognize. That said, a surviving Megalodon could not remain completely hidden in the modern era if its population were healthy and its range broad. Eventually, there would be repeated signs. The most realistic path is not total secrecy, but very late formal recognition. Marine science might spend decades circling the truth before naming it outright. A series of unexplained injuries on whales, acoustic data suggesting something enormous moving through known migratory lanes, the occasional impossible image from a deep-sea drone, a carcass, a pup in the wrong place at the wrong time, a satellite tag meant for a whale recording sudden, bizarre motion followed by silence. Discovery would likely come through accumulation, not a single dramatic reveal. Still, for that accumulation to happen only recently, the species would have to be both rare and behaviourally elusive. Those are not weaknesses. They may be exactly what kept it alive. Animals persist when they avoid becoming easy problems for humans to solve. The giant panda survived not by being elusive in a threatening way, but by inhabiting certain refuges and existing at densities that made its disappearance slow and tragic rather than sudden. Large sharks have survived in many places by being mostly absent from the specific waters where humans spend time announcing their mastery over nature. A megalodon that hugs remote depth gradients and follows prey far from coasts would benefit from the same accidental shield. Another issue is lifespan. If the species lived a long time, that could help maintain population stability despite low reproduction. Many large marine animals are long-lived. A megalodon that matured slowly but survived for decades would not need to reproduce often if adult mortality remained low. And adult mortality, for something that large in open water, might indeed be quite low except where humans interfered. That changes the arithmetic. A species with few births but very durable adults can persist for a surprisingly long time, provided juvenile recruitment does not collapse completely. That is a fragile system though. It works until it does not, which is why any modern megalodon population would probably be vulnerable even if it had managed to survive this far. Pollution and industrial impacts deserve mention too. Modern oceans are loud, they are chemically altered, plastics move through them, fishing gear drifts through them, heavy metals accumulate in top predators. If Megalodon were alive now, these problems would affect it, especially because apex predators often carry the toxic burden of the food web. That means survival to the present would not imply perfect health or abundance. It may imply a declining species that only recently came to science's clear attention because modern tools improved just as its population entered dangerous territory. That would be a very human kind of timing. We discover the giant just in time to realise we have already made its future difficult. There is also the possibility that surviving megalodons would alter their daily and seasonal rhythms to reduce stress. They might hunt more in low light. They might avoid major shipping corridors acoustically. They might shift depth in response to vessel traffic. Some modern marine animals already do this. Whales change song patterns. Fish alter movement around noise. Sharks modify behaviour under pressure. Over millions of years, a lineage that tolerated or preferred remote lower disturbance habitats would be favoured. What survives is not simply what is strongest, but what can still function when the environment becomes crowded, loud, and inconvenient. All of this starts to build a version of the animal that is more believable than the simple fantasy. Not an immortal sea monster untouched by time, but a highly reduced, highly adapted, wide-ranging, slow-breeding, selectively distributed top predator clinging to the best parts of the ocean. Still huge, still extraordinary, still one of the most dangerous animals on the planet in a direct encounter. But not everywhere, not abundant, not careless. In a sense, survival would require Megalodon to become less like a legend that wants attention, and more like a serious animal trying very hard not to waste energy or attract trouble. Which leads to a useful conclusion. If Megalodon were still alive today, it would probably be alive because the world had room for only a little of it. A few good habitats, a few productive routes, enough prey, enough warm water, enough successful births, enough distance from us. That is how giants continue. Not by conquering everything, but by finding the narrow set of conditions under which their size remains possible. And once you accept that, the next practical question is unavoidable. Because if such a predator did make it into our age by following the last favourable parts of the sea, then those places would matter enormously. The real issue would no longer be whether it survived in theory, but where exactly a modern giant shark of that kind could still make a home. That is the next practical step, because once you accept that a surviving megalodon would need a very specific kind of modern life, the question stops being, could it be anywhere, and becomes, where would the ocean still make sense for it? Giant predators do not live in places simply because those places feel dramatic to us. They live where the energy adds up, where the water temperature works, where the prey is worth the travel, where young can grow without immediately becoming somebody else's lunch. If Megalodon were alive now, it would not be haunting random stretches of sea for theatrical effect. It would be following opportunity with all the cold practicality that large animals tend to bring to their schedules. The first thing to say is that it probably would not live in the deepest parts of the ocean in the way people often imagine. This is one of the most persistent habits of the human mind. When faced with a large, frightening animal, we like to assign it to the darkest possible place and let the darkness do half the work. Trenches, abysses, bottomless black water. It feels right emotionally. It feels like the sort of place a surviving prehistoric giant ought to rent a flat. The problem is that the deep ocean is not automatically a good home for a massive active predator. It is vast, yes. It is hidden, yes. It is also relatively poor in the kind of large prey a megalodon-sized hunter would need on a regular basis. You do not support an animal of extreme size on atmosphere alone, no matter how menacing the atmosphere may be. That does not mean a modern megalodon would never descend into deeper water. Quite the opposite. It probably would use depth strategically. Many large marine animals do, but there is a difference between using deep water and living entirely in the sort of trench that internet documentaries mention, in a voice usually reserved for haunted staircases. A giant shark needs access to productive food webs, and productive food webs in the sea are often concentrated around particular zones, not in the most remote and barren depths. So if Megalodon survived, its true habitat would likely be tied to the upper and middle layers of the open ocean, especially around places where prey travels, feeds, breeds, or becomes predictably vulnerable. Warm and temperate waters would probably be the main stage. Fossil evidence suggests Megalodon favoured warmer seas, and that makes biological sense. Large sharks can tolerate a range of conditions depending on physiology, but a species built around gigantism, fast growth, and marine mammal predation would do best where energy is not being constantly drained by cold environments. So if it lived now, the most likely range would include tropical and subtropical waters, with seasonal excursions into cooler regions where prey became abundant enough to justify the trip. This would already narrow the map considerably. Not every coast, not every basin, not every place where someone once saw a strange wave and felt personally challenged by it. Picture broad belts of ocean rather than isolated horror spots. The Western Atlantic, for instance, with its warm currents, migratory marine mammals, and complicated shelf edges. Parts of the Indian Ocean, where large marine fauna move along productive corridors. Regions off southern Africa, where cool and warm systems meet and life gathers in astonishing concentration. Sections of the Western Pacific, especially near island chains, continental margins, and routes used by whales. Not because those places sound exciting on a map, though they do, because they combine the ingredients that matter: warmth, prey, space, and movement. Continental shelf edges would be especially interesting. These are transitional places where shallow seas give way to deeper water, and they are often biologically rich. Nutrients, currents, schooling fish, squid, marine mammals, and a variety of predators all interact there. For a giant shark, shelf edges offer a useful compromise, close enough to coastal productivity to exploit dense food webs, far enough from shore to avoid constant contact with humans. A modern megalodon might spend much of its time along these margins, cruising the long underwater boundaries where prey passes between deep and shallow worlds. To us, these regions are lines on marine charts. To an apex predator, they are potential highways. That sort of habitat would also suit an animal trying to remain difficult to observe. Offshore shelf breaks are not empty, but they are much less watched than beaches and harbours. Fishing vessels pass through, research ships pass through, merchant traffic crosses some of them, yet most of the water there goes unexamined in detail. A large predator could move through such areas with a surprising degree of privacy, especially if it preferred certain depths during the day and changed depth only when feeding or travelling. This is one of those cases where the modern world feels more monitored than it actually is. We have excellent technology in specific places for specific tasks. We do not have a permanent close-up portrait of the ocean at all times. Another likely habitat would be migratory corridors used by whales. This almost feels too obvious, but obvious things are often right. If Megalodon fed heavily on marine mammals in the past, then any surviving population would likely remain tied to the broad seasonal movements of large prey. Whales migrate between feeding grounds and breeding grounds, often along fairly consistent routes. That makes them both elusive and predictable, which is exactly the sort of balance a giant marine predator would appreciate. You do not need prey that is always present if you can rely on it being present at the right time, in the right place, and in sufficient density to make the trip worthwhile. This means certain ocean passages could become crucial. Not everywhere whales exist, but where their routes narrow, where coastlines shape their movement, where warm breeding waters attract mothers and calves, and where an experienced predator could intercept them efficiently. The key word there is efficiently. A giant shark burning huge amounts of energy would not waste effort chasing impossible meals across empty water. It would position itself where probability improved. Nature tends to reward patience in big predators. People imagine violence. Ecology usually prefers timing. Remote island systems might also matter more than most people realise. Islands do interesting things to the ocean. They interrupt currents, they create upwelling. They attract fish, squid, seabirds, seals, and marine mammals. Their slopes drop sharply into deep water. They produce edges, and edges are often where life thickens. A megalodon would not need land, of course, but island arcs and volcanic seamount chains could provide excellent routes and feeding zones. A large predator could move from one productive area to another along these underwater stepping stones, using them as part of a much larger roaming system. To human eyes, an island might look isolated. To marine life, it can be a junction. There is also the question of nurseries, and this is where the map becomes more delicate. If modern megalodons still reproduced in a way similar to their ancient relatives, then they would need areas where juveniles could grow with relatively low competition from adults and a manageable risk from other predators. Historically, shallow, warm coastal waters may have played this role. Today, that would be much more complicated. Many coastal nurseries are noisy, polluted, overfished, or crowded with human activity. So a surviving population would either need the last remaining suitable coastal refuges or a modified nursery strategy altogether. One possibility is that young Megalodons would use broad, shallow banks far from heavily populated coastlines. Places warm enough for growth, rich in medium-sized prey, but distant enough that a 2-metre newborn shark does not immediately become an international news item. Another possibility is the use of semi-enclosed seas or protected warm basins with limited human intrusion. Yet another is that nursery behaviour has shifted offshore over evolutionary time, with juveniles growing around isolated ridges, seamounts, or open water food zones where adults appear only seasonally. That may sound less dramatic than a hidden lagoon, but it is far more believable. Real animals persist through workable compromises, not because they discovered a secret cave with good acoustics. Because people like drama, there is also a strong temptation to place surviving megalodons near famous mysteries, the Mariana Trench, the Bermuda Triangle, any place that already comes with rumours attached. This is understandable, but not very useful. The Bermuda Triangle, for instance, is much more interesting as an example of human storytelling than as a zoological address. A giant predator does not choose a home because newspapers have been unwise there before. It chooses a home because the prey field supports it. The same goes for trenches. They are fascinating environments, but not likely permanent housing for a hunter of very large mobile prey. The ocean is strange enough on its own. It does not need us assigning every impressive animal to the first spooky region that comes to mind. A more realistic pattern would be a wide but patchy distribution. Adults would likely spend much of their time in pelagic waters, crossing enormous distances between favoured zones. They might not be residents in the way coastal sharks are residents. They might be more like seasonal visitors to certain regions, appearing when prey appears, then vanishing again into open water. This would make local sightings inconsistent and frustrating. One season, a cluster of unexplained whale injuries, another, nothing. 1 year, deep acoustic anomalies off an island chain. The next, silence. Humans are uncomfortable with intermittent patterns. We prefer either complete certainty or complete nonsense. A real Megalodon population would likely offer neither. Depth use would probably be dynamic. During the day, adults might cruise deeper, especially in warm regions where the surface becomes energetically less comfortable or too exposed. At night, they may rise, following prey that vertically migrates, or approaching the upper layers when visibility is reduced. Some modern sharks already show complex vertical movement, adjusting to prey behaviour, temperature, and light. A giant descendant would likely be no less practical. This could also help reduce encounters with humans. Beaches and the immediate coastal surface are where people imagine all shark life happening because that is where we are. The sharks themselves may find the rest of the water more sensible. There is another factor that would shape habitat, and that is sound. Modern oceans are loud, shipping noise spreads widely, military sonar, seismic surveys, industrial operations, fishing fleets, tourism vessels, and dense traffic all create an acoustic environment very different from the seas of the past. Large marine animals often respond strongly to sound. Whales do, fish do. Sharks, though less discussed in this context, are still animals living in a medium where vibration and low-frequency cues matter. A surviving Megalodon might avoid chronically noisy regions not because the sound is painful in some melodramatic sense, but because it interferes with orientation, hunting, or basic comfort. Over time, this could push populations toward quieter stretches of ocean, farther from major shipping arteries and heavily industrialized coasts. That would create a curious pattern. The very places where people most confidently assume they have the ocean under control might be the places Megalodon least prefers. Busy ports, heavily trafficked approaches, crowded resort coasts and industrial shelves could function as partial acoustic deserts for such an animal. Meanwhile, remote sectors with healthier prey and less disturbance could become strongholds. It is a mildly humbling thought. The giant may not be hiding from us exactly. It may simply have developed a strong preference for areas where we are less irritating. Food availability would shape the map even further. A home range for a predator that size would not be defined by property lines or tidy circles, but by movement between feeding opportunities. If whales are central prey, then breeding grounds, migration routes and feeding areas all matter. If large fish, squid and scavenged carcasses supplement the diet, then ocean fronts and productivity zones matter too. Upwelling regions where nutrient-rich water rises and feeds dense marine life become important. They attract the base of the food web, which builds the layers above it. And whenever the sea starts building layers efficiently, predators begin arriving as though invited. So imagine a Megalodon's world not as one layer, but as a rotating schedule, warm water transit corridors, seasonal whale intersections, offshore shelf edges, certain island margins, particular fronts where ocean conditions gather life reliably. A giant shark might move through these places the way nomadic herbivores move between grazing grounds or large birds move between breeding and feeding sites. Not aimless wandering, structured roaming. That makes the species easier to imagine and harder to pin down, which is, from the shark's point of view, ideal. It also means that some of the places humans love most would occasionally overlap with its routes. That is where tension begins. Tropical channels near island nations, warm offshore banks near tourist economies, whale-watching zones that also happen to be sensible interception areas for an ancient predator. Suddenly, paradise requires additional paperwork. This does not mean every beach becomes unusable, far from it. A rare giant predator would not blanket coasts with constant danger. But certain stretches of water might acquire reputations, and not the sort tourism boards frame nicely. Some islands would quietly become known among sailors and fishermen as places where the sea feels bigger than expected. Every maritime culture has waters it treats with a little extra seriousness. In a Megalodon world, those cultural maps would likely be very specific. Polar waters, by contrast, are less likely permanent habitat, though not impossible for temporary visits if prey abundance warranted it and physiology allowed. The colder and less energetically forgiving the water, the more expensive giant life becomes. A modern megalodon might occasionally enter cooler regions along prey routes, much as some large sharks and whales do now, but it would probably not make those places its main residence. This matters because it removes a certain cinematic temptation. The giant is less likely to spend its time erupting through Arctic gloom for the convenience of documentary trailers. Realistic habitat is usually less theatrical and more repetitive. Nature likes systems, we like scenes. There is also no good reason to place it in enclosed bodies of water, such as the Mediterranean in a stable long-term sense, unless very specific corridors and prey systems supported a small seasonal presence. Large predators can enter semi-enclosed seas, of course, but long-term persistence there depends on prey, movement freedom, and reproduction. The larger the animal, the less forgiving the map becomes. In open basins with strong human presence and limited large prey, the economics are poor. A giant shark must think like a giant shark, not like a villain selecting a dramatic hideout. Another thing to bear in mind is that habitat would likely vary by age class. Juveniles would not occupy the same spaces as the biggest adults if that could be avoided. Smaller animals face different risks and eat different prey. Subadults might use warmer, more productive shelf waters where medium-sized prey is abundant. Adults may remain farther offshore, intersecting only occasionally. This age separation is common in sharks, and would make even more sense in a lineage this large. It would also complicate discovery. A small juvenile seen once may not immediately be recognised for what it is. A colossal adult seen at sea may be too brief or too poorly documented to settle anything. The life stages would hide each other by occupying different versions of the ocean. And then there is the question of whether it would stay mostly in the southern hemisphere, the northern hemisphere, or both. If prey and climate allow, probably both, though not uniformly. Marine predators do not care for our preference that the globe behaves symmetrically. They follow living patterns, not cartographic elegance. Certain basins would be more suitable than others based on temperature structure, prey migrations, and human pressure. The result might be a ringed, irregular set of strongholds, rather than a grand global kingdom. Enough to be real, not enough to be easy. All of this points toward a version of the animal that belongs not to one hidden cave, but to the architecture of the living sea. It would inhabit routes more than addresses, systems more than spots. Productive boundaries, migratory passages, warm nursery refuges, quieter offshore margins. The home of a modern megalodon would not be a point on a map you could circle once and announce the mystery solved. It would be an ecological pattern spread across thousands of kilometres of ocean, appearing only where enough conditions overlapped to support a hunter too large to make careless choices. And that, in turn, tells us something important about daily life for such a creature. If its home is defined by productivity and movement rather than one fixed realm, then hunger would be the great organiser of its schedule. Where it lived would always come back to what it could eat, when it could find it, and how efficiently a giant body could turn the living ocean into enough energy to keep going. And that is really the centre of it, because once you start imagining a megalodon alive in the present, every road leads back to food. Size is impressive, teeth are impressive, habitat is important, but hunger is the real engine. A giant predator does not continue existing because the world finds it exciting. It continues existing because the ocean keeps paying the bill. Every kilometre it swims, every rise from depth, every turn of that enormous body through the water, every developing pup, every surviving adult, all of it runs on calories. If Megalodon were still alive today, then the first practical fact of its life would be that it needed to eat a lot, and it needed to eat things worth eating. This tends to sharpen the imagination very quickly. People hear giant prehistoric shark and immediately picture dramatic attacks, perhaps a submarine in distress, perhaps a yacht with terrible luck, perhaps somebody in a wetsuit discovering that confidence is not a defense strategy. But from the animal's point of view, that sort of chaos would make little sense as a routine. Real predators do not stay alive by taking noisy, risky, energetically inefficient opportunities just because they are memorable to us. They stay alive by selecting prey that offers the best return for the least unnecessary trouble. That rule becomes even stricter as body size increases. A giant hunter cannot afford to be theatrical, it must be practical. So the first question is not whether Megalodon could eat almost anything. In a broad physical sense, it probably could overpower a frightening range of marine animals. The better question is what it would choose to eat most, often if it were making a successful living in modern seas. The answer is likely large, energy-rich prey, especially marine mammals, with a healthy dose of opportunism whenever the opportunity was good enough to justify it. Whales would almost certainly be central to the story. That does not mean every whale, all the time, in every part of the ocean. A predator that large would probably focus on particular species, particular age classes, and particular circumstances. Not all prey is equally sensible. A full-grown healthy adult blue whale is not a meal so much as a moving engineering challenge, and even a giant shark would have to think carefully before turning that into a workday. A calf, however, or a juvenile, or an already weakened individual, or a whale in a geographically constrained migration route, that is a more plausible target. Baleen whales would be especially important because they package a huge amount of fat, muscle, and energy into a body that, under the right conditions, can be intercepted. Fat matters a great deal here. Marine mammals are, from a predator's perspective, extremely valuable. Blubber is dense energy. An animal the size of Megalodon would benefit enormously from prey that repaid effort in bulk. Hunting 1,000 medium fish is not the same proposition as securing a large marine mammal. This is one reason giant marine predators tend to be drawn toward prey of substantial size when they can manage it. In ecological terms, a good whale is not simply food, it is efficiency. That said, efficiency is not only about the amount of energy in the prey, it is also about the cost and danger of getting it. Whales are not passive floating containers of nutrition. They are large, mobile, often social, and quite capable of making life difficult for anything that approaches unwisely. Some species are fast, some travel in groups, some mothers defend calves with astonishing force. A megalodon would likely prefer situations where the odds were already tilted in its favour. Migration bottlenecks, breeding grounds, nursery areas, or places where whales were resting, surfacing frequently, or moving through warmer waters with calves. A giant predator does not need to be fearless if it can simply be patient. Calves and juveniles would probably be especially important. That may sound cruel in the way nature often does when translated into polite evening language, but it makes ecological sense. Young whales are smaller, slower, and less experienced. They also carry a large amount of valuable fat. In modern oceans, many whale species use warm, shallower waters as calving grounds. If megalodons still existed, those grounds would likely be far more tense places than we currently understand them to be. Whale behaviour itself might be different as a result. Mothers may keep calves tighter to shore in some places, or farther offshore in others, depending on what long experience had taught the species about where giant sharks were most likely to patrol. That alone suggests an ocean subtly reshaped by predation pressure. A modern observer might think a whale migration route is simply where whales prefer to go. In a megalodon world, that route could also be where they have learned to survive best. Predators and prey write each other's habits over time. A giant shark does not merely take from the sea, it edits it. Still, whales would not be available every day in every place, and no successful predator can build its life on rare banquets alone. So Megalodon would likely need a broader menu, not because it wanted variety, but because survival tends to reward flexible appetites. Large pinnipeds, such as elephant seals, sea lions, and some other substantial marine mammals, would be logical prey in regions where they are abundant. They are rich, relatively large, often predictable in movement, and in some cases forced through concentrated zones between feeding grounds and haul-out sites. Modern great whites already exploit seal colonies with impressive efficiency. A megalodon in the same broad system would probably use similar opportunities when they met its size requirements. There is a complication though. Close coastal hunting increases the chance of human interaction. If surviving megalodons had endured into the modern era partly by avoiding us, then adults might not routinely approach famous seal colonies near busy coasts, at least not in daylight, and not if more profitable offshore options existed. Subadults, perhaps. Regional specialists, perhaps. But the largest mature individuals would likely find their best returns farther out, where the prey is bigger and the audience is smaller. Coastal pinniped hunting might be part of the diet, but not necessarily the main foundation of it. Large fish would almost certainly be taken as well, especially tuna and other powerful pelagic species. Now, compared with whales, a tuna is a modest meal for a giant shark, but a truly large tuna is still packed with muscle and oil, and schools or aggregations of sizable fish can provide decent returns if encountered at the right time. Swordfish, big rays, other sharks, and perhaps even large bony fish moving along productive fronts could all enter the menu depending on region and opportunity. Nature does not usually ask predators to swear loyalty to a single category. It asks them to remain alive. Other sharks might indeed be prey from time to time. Large predatory sharks already interact through competition, avoidance, and occasional outright violence. A giant megalodon would dominate most of those interactions physically. Great whites, tiger sharks, macos, sleeper sharks in the right regions all might have reason to avoid a mature adult. Juvenile megalodons, of course, would live in a more complicated world and might themselves face pressure from other large predators until they reached safer size classes. A shark lineage that size likely began life with a great deal of incentive to grow quickly. Scavenging would probably play a bigger role than people tend to imagine. There is a certain romantic preference for predators to earn every meal in a dramatic fashion, but scavenging is one of nature's finest ideas, and top predators rarely ignore it when it is available. A dead whale floating or sinking through the water is an enormous deposit of energy. It attracts sharks, fish, birds, invertebrates, and eventually deep-sea communities if it reaches the seabed. A megalodon encountering such a carcass would have every reason to feed heavily. In fact, a species with large roaming ranges may rely on scavenging as a valuable supplement between major hunts. Not because it is desperate, but because refusing free blubber would be idiotic. This matters because it increases the plausibility of survival. A giant shark that only thrives by successfully hunting live whales on a regular basis has a very narrow economic model. A giant shark that can also exploit carcasses, injured prey, fish concentrations, pinniped roots, and occasional large marine reptiles if they happen still to exist, though thankfully for accuracy they do not, becomes much more flexible. Flexibility is the friend of survival. Pure specialization makes for striking documentaries and risky futures. There is also the question of how often such an animal would need to feed. Very large predators do not necessarily eat every day in the way smaller active animals might. A successful major kill could support a giant shark for a substantial period, especially if its metabolism, while powerful, was still optimized for efficiency in open water. After a large meal, it might travel, digest, descend, and move more slowly before the next major feeding opportunity. This would make direct observation even harder. People tend to imagine constant hunting because suspense prefers busy schedules. Real large predators often alternate between intense effort and long strategic quiet. The style of attack would depend on prey, but fossil evidence gives some clues from ancient behaviour. Megalodon appears to have bitten whales in ways that disabled them quickly, perhaps targeting fins, the chest, or other critical regions. That suggests a predator designed not merely to bite hard, but to solve the movement problem. A giant prey animal is dangerous if it remains mobile. Stop its speed, ruin its steering, weaken its ability to dive or surface and control, and the equation changes. A modern megalodon would likely use similar logic. One can imagine a strike from below or from the side, not random but timed, intended to cause massive blood loss, shock, or loss of maneuverability. Not all predators kill instantly. Many kill by tipping the odds until the outcome becomes inevitable. That makes calf hunting especially plausible. A large calf separated briefly from its mother or slowed during migration would be the marine equivalent of a financially sound decision. Again, this is not because the shark is cruel. Cruelty is a moral category. This is because evolution does not hand giant predators the privilege of being sentimental about logistics. Would Megalodon eat humans? That is the question that arrives on schedule every single time, usually wearing slightly nervous shoes. The truthful answer is that humans would almost certainly not be preferred prey. We're not especially energy-rich compared with marine mammals. We do not move like normal ocean prey. We spend relatively little time in the open sea compared with whales, fish, and seals. Most of us are also attached to boats, shorelines, flotation devices, panic, or all four. A giant shark built to hunt marine megafauna would not evolve around human consumption, because humans have not been a consistent part of the open ocean prey field long enough to justify it. However, that does not make humans safe in an absolute sense. Any large predator can injure or kill a human under the wrong circumstances. Curiosity, mistaken identity, territorial reaction, opportunistic attack on small craft, investigation of unusual movement in the water, these are all possible. In remote waters, especially if a person were alone, far offshore, and behaving in a manner that strongly resembled a distressed animal, things could go very badly. But if we are asking what a megalodon would eat today as part of its actual ecological life, then humans belongs far down the list, more in the category of occasional incident than dietary pillar. This may be cold comfort to the occasional incident. Small boats raise a similar issue. The public imagination loves the idea of giant sharks attacking vessels, but from an energy perspective, boats are useless. They are hard, noisy, and nutritionally disappointing. A Megalodon would not be out there chewing fiberglass because it contained hidden vitamins. That said, a boat associated with struggling fish, blood, discarded catch, marine mammal carcasses, or unusual acoustic cues could attract attention. A strike or bump may occur not because the shark wants the boat, but because the boat has inserted itself into the sensory space of feeding. That distinction would matter greatly in any real management plan, though it would be little comfort to the management team writing unplanned physical contact with unknown large fauna in the report. There is another fascinating possibility. If Megalodon survived into the modern age, it might also exploit the industrial side effects of human activity. Fishing fleets create concentrations of injured animals, offal, bycatch and acoustic signatures that predators learn to associate with food. Many modern sharks already follow vessels for exactly this reason. A giant intelligent in the ecological sense, not necessarily in the orca sense. Predator could learn that certain human patterns lead to feeding opportunities, not by hunting people, but by scavenging around our inefficiency. This would make it more likely to appear near longline operations, whale carcass disposal zones, or regions where fisheries overlap with marine mammal movement. That creates a strange picture of coexistence. Humans might not be on the menu in the ordinary way, but our systems would still feed the shark indirectly. We would become part of its ecology whether we liked it or not. That is often how large wildlife works. We do not need to be edible to be relevant. Seasonality would matter too. In some times of year, the shark might focus heavily on whales. In others, fish runs or pinniped movements may dominate. In still others, especially if prey becomes scarce, scavenging might become proportionally more important. A modern Megalodon would not necessarily have a fixed menu any more than a modern bear does. It would have profitable seasons, lean seasons, and routes shaped by the calendar of the sea. This is one more reason it could remain difficult to pin down. The animal in one region in one month may behave quite differently from the same species elsewhere or later. Juveniles would have a different diet from adults, and that is important. A newborn or young Megalodon, even if already alarmingly large by ordinary standards, would still not be hunting whales. It would likely begin on substantial fish, smaller sharks, rays, squid, perhaps juvenile marine mammals were available. As it grew, its prey would scale upward accordingly. This ontogenetic shift, as biologists put it, when they are trying to sound calm about a shark outgrowing one menu and moving to another, would reduce competition between age classes and make survival more plausible. A species in which the young and the adults exploit slightly different food webs is easier for the ocean to support. There is also an interesting possibility involving carcass sinking events. When a whale dies naturally or from predation, it creates a temporary feast at the surface, and then a long deep sea bonanza if it sinks. A large shark able to track such events by scent over great distances could benefit enormously. Scent travels in water. Chemical cues matter. A Megalodon may be able to arrive at a carcass from far beyond the range at which we would imagine a shark noticing it. That means part of its diet might come from a kind of roaming opportunism, not random in the sense of being accidental, but broad in the sense of exploiting the full range of marine death. It is not glamorous, but neither is starving. And then there is the role of competition. Orcas, large sharks and other scavengers would not politely step aside. A Megalodon at a carcass or kill might dominate by sheer size, but there would still be trade-offs. Social predators can harass larger solitary ones. Multiple modern sharks can converge on the same resource. The shark's diet would be shaped not only by what it could eat, but by what it could hold, defend, or consume quickly enough to justify the effort. This is one reason a bite force like Megalodon's matters beyond simple violence. The faster you can open a prey item, remove dense tissue and secure energy, the less time you spend negotiating with the rest of the ocean. The more you think about it, the clearer the picture becomes. A living Megalodon would not eat everything. It would eat the ocean's richest opportunities. Young whales, weakened whales, certain adult marine mammals under favourable conditions, large fish when profit exceeded effort, pinnipeds where roots and risk made sense, carrion whenever the sea provided it. Juveniles would rise through smaller but still substantial prey before graduating into the upper levels of marine economics. It would be less a creature of indiscriminate appetite and more a specialist in large returns, softened at the edges by opportunism. That may not sound as wildly cinematic as a shark swallowing whatever happens to cross its path, but it is actually much more unsettling in a realistic way. An indiscriminate monster is chaos, a giant predator that knows exactly what it is doing and exactly what prey is worth the energy is a functioning part of the world. And functioning parts of the world leave consequences. If Megalodon were still feeding in modern seas, it would not only change the fate of individual animals, it would alter migration routes, population pressures, and the daily decisions of life across entire marine systems. The question would no longer be simply what the shark eats, but how the rest of the ocean behaves when something that large is still hungry. The question would no longer be simply what the shark eats, but how the rest of the ocean behaves when something that large is still hungry. Because predators do not just remove bodies from an ecosystem. They change schedules, they change routes, they change nursery choices, group behaviour, feeding times, resting places, and sometimes the entire emotional tone of a stretch of water, if one may briefly allow the ocean a mood. A surviving megalodon would not simply add another mouth to the sea, it would rearrange the habits of life around it, from the largest whales down to the smaller predators, trying not to become somebody else's compromise. That kind of influence is something ecologists take very seriously. Top predators often shape ecosystems in ways that go far beyond direct predation. Wolves change where deer graze. Sharks can change where seals rest or travel. Orcas can alter the behaviour and even the abundance of large prey across huge distances. This is called a trophic effect, though the phrase sounds much tidier than the reality. In practice, it means that when something dangerous is present, other animals start making different decisions, and those decisions spread through the food web in ways that can become surprisingly large. Add Megalodon to the modern sea, and you're not just adding one more predator, you're adding a major organising force. The first animals to react would be marine mammals, especially whales. If Megalodon hunted them regularly enough to matter, then whale life in the modern ocean would look different almost immediately, and in some cases very differently over evolutionary time. Migration routes, for one thing, would likely shift. Right now, whales move along routes shaped by food availability, breeding needs, temperature, and historical patterns. In a world with Megalodon, predation pressure would join that list in a serious way. Some routes would become less favourable, especially if they exposed mothers and calves to repeated interception in warm coastal waters or predictable offshore corridors. Other routes might lengthen, bend, or move into less ideal feeding or breeding conditions simply because surviving the journey mattered more than convenience. This happens in nature all the time. Animals do not always live where conditions are perfect. They live where conditions are acceptable, and acceptable often means not being eaten. So a whale species might choose a slightly poorer breeding ground if it offered better odds against giant sharks. Calving areas might shift closer to shore in some places, farther offshore in others, depending on how local geography affected risk. Some species might bunch more tightly, others might spread out more to reduce predictability. In either case, the map of the ocean would begin to carry the shape of fear in practical, measurable ways. That word can make people uncomfortable. Fear sounds dramatic and emotional. In biology, it is often simply a sensible system of behaviour. A calf staying closer to its mother is fear translated into survival. A pod avoiding certain channels during a given month is fear translated into migration strategy. A species breeding in less productive but safer waters is fear translated into population structure. Predators create not just mortality but caution, and caution is one of nature's great architects. Whale mothers, especially, would likely behave differently if a giant shark remained part of the world. Many whale calves are already vulnerable in their earliest months. They need to surface often, they are slower than adults, and they have not yet learned the full practical meaning of danger, which, to be fair, is true of the young in nearly every species, including ours. In a megalodon world, maternal behaviour might become more aggressive, more defensive, and more localised. Calves may remain in tighter formation. Pods may create more protective spacing. Some species might evolve to calve in seasons or areas that reduce shark presence, even if those seasons and areas were otherwise less than ideal. The long-term effect of that could be substantial. Body size, growth rate, migration timing, even social structure might slowly shift under persistent predation pressure. We often think of evolution as being shaped mainly by climate or food, but predators are just as capable of writing changes into the bodies and behaviour of prey. A whale species heavily targeted as juveniles might evolve faster early growth. Another might alter the fat reserves of calves. Another might breed in more protected waters. Over enough time, the ocean would not simply contain whales and megalodons. It would contain whale species already shaped by millions of years of not wanting to become megalodon food. Seals and sea lions would react too, though probably in more regionally specific ways. Modern pinnipeds already deal with sharks and orcas, so they are no strangers to difficult mornings. Add a predator much larger than a great white, and colonies in certain locations might become far more cautious about water entry and exit. Haul-out behaviour could shift. The timing of foraging trips might change. Juveniles may stay closer to shore or in larger groups in risk-heavy seasons. Some colonies might decline in places where access routes to feeding grounds became too exposed. Others might thrive in geographic refuges where giant sharks could not approach as effectively or did not bother to. The same would be true for dugongs, manatees in some regions if ranges overlapped suitably, and perhaps larger sea turtles, though turtles would be less ideal prey than marine mammals from an energy perspective. Even if Megalodon did not target such animals often, its presence would still alter their behaviour if encounters were dangerous enough to matter. Predators do not have to specialise in you to make you nervous. Sometimes being eaten occasionally is plenty persuasive. Large fish populations would also shift under the pressure of a surviving giant shark. Tuna, billfish, large rays, and substantial schooling species moving through productive ocean fronts would likely behave differently in waters where a super predator still roamed. That might mean deeper daily movement in some places, altered schooling density, or changes in seasonal aggregation. It might also affect commercial fisheries in odd ways. Fishermen often read the sea by where life gathers. If life gathers differently, fisheries change, and people may not immediately realise that the reason a school no longer forms in a certain place is not current temperature alone, but that a bigger decision maker has entered the scene. Other sharks would probably be among the most visibly affected. Great whites, tiger sharks, makos, and large pelagic species do not live in a vacuum. They compete, they avoid, they overlap, and sometimes they lose. A living megalodon would almost certainly dominate much of that world physically. This does not mean it would hunt other large sharks constantly, but it would not need to. Presence alone could displace them. Great whites might remain abundant in cooler waters or in certain coastal hunting systems where a giant megalodon was less likely to operate. Tiger sharks might hold their ground in warm coastal and reef-heavy regions where they are flexible and opportunistic. Makos might stay in their high-speed pelagic niche. But all of them would be living around a larger predator that could outbite, outmass, and probably out-intimidate them whenever serious overlap occurred. That kind of pressure could create a sort of partitioned ocean. Not empty zones and occupied zones, but gradients of dominance. In some waters, great whites might be the top shark because Megalodon passes through only rarely. In others, especially major whale routes and rich offshore corridors, even the largest modern sharks might behave like second-tier hunters, taking what they could get while staying aware that something larger may arrive at any moment. There is a good chance that some shark species would be noticeably smaller or less abundant in those places, because the ecological ceiling would already be occupied. Orcas deserve special attention, because if there is any modern marine predator capable of complicating a Megalodon's sense of authority, it would be them. Orcas are large, social, intelligent, and capable of coordinated hunting that makes many other predators look positively underprepared. A solitary giant shark is formidable. A group of determined orcas is the sort of problem nature invented to remind everyone that teamwork can be rude. So the relationship between orcas and megalodons would be one of the most interesting consequences in the whole system. Would adult megalodons and orcapods fight directly on a regular basis? Probably not, because both parties would have every reason to avoid expensive injuries. But would they compete for prey, harass one another around carcasses, and alter each other's movement patterns? Almost certainly. Orcas might target juvenile megalodons if given the chance. Adult megalodons might steal kills or dominate certain feeding opportunities through sheer size. In response, orcas might become even more strategic about where they hunt whales, when they approach carcasses, and how they move calves through risk-prone water. In some regions, orcas might push giant sharks away through coordinated harassment. In others, the shark's presence might be enough to keep pods from lingering. The sea would become a little more political. Sperm whales would likely react differently from baleen whales. Adult sperm whales are not easy prey. Large males are enormous and powerful, and sperm whales in groups can mount serious defences. Females and young, however, might still be vulnerable in some settings. If Megalodon threatened them enough to matter, sperm whale social organisation and movement might also change, with tighter grouping in dangerous waters or altered use of depth during transit. This is worth noting because sperm whales already spend much of their lives balancing deep foraging with surface vulnerability. Add another large predator to that equation, and the balance becomes more delicate. Then there is the effect on scavengers. Whale carcasses are important events in the ocean. Sharks, fish, seabirds, crustaceans, and deep sea life all benefit from them. If Megalodon killed large marine mammals with any regularity, the number and distribution of carcasses or partial carcasses entering marine systems could increase in certain regions. That would feed scavenger communities. It would enrich some deep-sea food falls. It might even affect benthic ecosystems below migration routes where more remains drift downward. So oddly enough, a giant predator at the top could end up supporting life far below through the leftovers of violence, which is not a cheerful sentence, but it is an honest one. This is how ecosystems often work. One animal's catastrophe is another animal's unexpectedly good week. Crabs, hagfish, sleeper sharks, amphipods, deep-sea microbes, all may profit from a big predator operating above them. The ocean is very efficient about not wasting what falls into it. A modern megalodon would therefore not only remove prey, it would redistribute energy. That energy would move through scavengers, decomposers, and the broader food web in patterns we might eventually detect if we were paying enough attention. Smaller predatory fish and mesopredators would probably feel the change too, though more indirectly. In systems where apex predators are present, mid-level predators often alter their own activity because the cost of becoming visible rises. This is called mesopredator suppression, though that phrase sounds like a problem an office printer might have. In ecological reality, it means that when something at the top is dangerous enough, medium predators stop behaving like they own the place. They forage differently, they spread out, they avoid certain times or depths. In a megalodon world, some mid-sized sharks and large pelagic hunters might be less bold in rich feeding zones because the risk of being displaced or killed would rise. That could benefit some prey species at intermediate levels. For example, if medium sharks become more cautious in certain regions, fish they would normally hunt might experience lower pressure there, at least seasonally. This is how top predators can create surprisingly mixed outcomes. They do not simply make all life worse for everything beneath them. They can reduce some populations while indirectly protecting others. Ecological influence tends to spread in branching lines rather than straight ones. Even seabirds might notice. though not in any way they could explain to a funding committee. If large fish schools or surface feeding events shift location because giant sharks alter predator-prey interactions below, birds that depend on those events will also shift. Entire feeding assemblages can be affected by where fish are pushed, where mammals surface, or where carcasses appear. A megalodon-rich corridor could become a place where certain birds reliably gather after kills, or where fish schools avoid the surface at key moments. The sky above the sea often reflects the structure below it more than people realise. Coral reef systems, on the other hand, might feel less direct pressure from adult megalodons unless those reefs were close to key transit routes or nursery areas. A giant shark focused on large pelagic prey is not likely to spend much time weaving through reef canyons for recreational purposes. Still, juvenile or subadult stages could interact with reef-adjacent food webs in warm regions, and the wider effects of prey movement could reach reef communities indirectly. If major fish species alter migratory timing or route selection because they are avoiding open water interception, coastal ecosystems that depend on those movements might also change. This is how one species can influence places it barely enters. Another major change would involve sound and behaviour at the population level. Marine animals communicate, orient and make movement decisions in ways we're still learning to interpret. If Megalodon remained in the system, some species might have evolved specific responses to cues associated with its approach. Changes in group density, sudden silencing, depth shifts, coordinated directional movement, all these may become part of the defensive language of the sea. Modern biologists, if they eventually recognise the pattern, might realise that certain unexplained whale or fish behaviours were actually anti-megalodon strategies refined over long stretches of time. It is a delightful scientific image, really. Thousands of researchers gathering data for decades, only to discover the ocean has been quietly reacting to a giant shark the whole time. Of course, none of this would be purely neat and balanced. There would be losers. Some marine mammal populations might be lower than in our world, especially species that could not easily alter breeding grounds or migration routes. Certain shark species may be rarer in zones dominated by the giant. Some fisheries might suffer because prey distributions became harder to predict. Conservation planning would become more complicated because a predator of that scale cannot be ignored, but neither can its prey. Humans do enjoy ecosystem management in theory, right up until the ecosystem insists on having multiple priorities. There is also the possibility that some prey species would become more robust because of Megalodon's presence. It sounds counterintuitive, but predators can strengthen prey populations by removing weaker individuals, reducing disease spread in some cases, and preventing overconcentration in risky areas. A giant shark may help keep whale or pinniped populations more mobile and less crowded in certain habitats. It may limit the number of weaker juveniles that survive only to struggle later. It may maintain a level of pressure that prevents prey from damaging parts of the ecosystem through overuse. Predation is not a moral service, but it can be an ecological one. Still, this is not a tidy story of balance restored by a noble ancient shark. That kind of sentence belongs on a poster with too much sunset in it. The realistic picture is messier. Some systems would become healthier, others more stressed. Some species would adapt beautifully, others would pay heavily for sharing the ocean with an apex predator from another era. The modern sea would be richer in one sense, more dangerous in another, and more structured by caution. Almost everywhere the giant mattered. And then there is the human side of marine life, because once the ocean begins reacting to Megalodon, people who depend on the ocean notice sooner or later. Fishermen notice when schools shift. Whale researchers notice when migration routes no longer match old patterns. Ecotourism operators notice when animals become less predictable. Conservation groups notice when calf survival changes. Beach communities notice when seals behave strangely offshore. We tend to think of marine ecology as something happening out there, apart from daily life, but in coastal worlds, those changes come home rather quickly. which means the larger story would not stop with whales, sharks, fish and scavengers adapting to a giant predator. Sooner or later, our species would have to adapt too. And humans being humans, we would respond with a mixture of awe, anxiety, overconfidence, warning signs, expensive technology, and at least one person who insists this is excellent news for tourism. Which means the larger story would not stop with whales, sharks, fish and scavengers adapting to a giant predator. Sooner or later, our species would have to adapt too, and humans being humans, we would respond with a mixture of awe, anxiety, overconfidence, warning signs, expensive technology, and at least one person who insists this is excellent news for tourism. At first, the effect on humans would probably not arrive as one single dramatic revelation. It would arrive in fragments. That is usually how big truths enter modern life, a strange bite pattern on a whale. A fishing boat crew reporting something absurdly large beneath them, and then being politely ignored at a conference. A damaged tag from a marine research project returning data that makes no immediate sense. A surfer in a place they absolutely should not have been insisting they saw a shark, far too large for the description to be socially acceptable. A cargo crew in the open ocean feeling a heavy impact against the hull and writing it up in the sort of restrained language humans use when they do not want to sound unserious on paper. That phase might go on for years, perhaps decades. The public would flirt with the idea in waves. There would be rumours, documentaries, grainy footage, podcasts featuring men with dramatic voices and suspicious certainty, and then the usual reaction from serious science, which would be caution, skepticism, and increasingly uncomfortable silence as the evidence slowly refused to go away. Then, once the evidence reached a point where denial began to feel more embarrassing than admission, everything would change at once. Not the shark. The shark would continue being a shark. Humans, however, would begin behaving like humans in the presence of a very large new fact. The first industries to feel it would be shipping and fishing, because those are the people who spend real time on the water and whose business cannot simply decide to stay home until the sea becomes less interesting. Shipping companies would want to know whether a Megalodon could damage large vessels. The answer would be complicated and not especially calming. A giant shark would not treat a container ship as prey. There is nothing nutritionally useful about steel, and an animal that size would not waste energy trying to bite its way through maritime engineering unless something about the vessel's sound, cargo, or nearby activity produced confusion or feeding behaviour. But a full-grown Megalodon would carry enough mass to strike smaller vessels with serious force if startled, investigating, competing over a catch or reacting to baited water. A direct collision with a small fishing boat, research boat or pleasure craft could be catastrophic without the shark having any particular interest in the boat itself. This is one of those distinctions that matters very much in biology, and almost not at all to the people taking on water. To the shark, it may be incidental contact. To the humans, it is still the kind of day that gets discussed for generations. Large commercial ships would likely be physically safe in most cases, but not irrelevant. Sound travels efficiently through water, and the movement of major vessels creates distinctive acoustic and hydrodynamic signatures. If megalodons learn to associate certain types of vessel activity with food, particularly fishing activity, offal discharge, or marine mammal concentrations near routes, then ships could become part of the behavioural landscape of the species. That would make shipping lanes not dangerous in the simple cinematic sense, but ecologically significant in a way maritime planners would find inconvenient. Modern shipping is built on predictability. Routes, schedules, fuel efficiency, insurance categories, hazard maps, all of it depends on reducing uncertainty. A living megalodon would introduce a strange kind of uncertainty, not because every voyage would be under attack, but because certain corridors might gain a seasonal risk profile that had to be taken seriously. If a whale migration route overlapped with a shipping lane and giant sharks concentrated there during a few key months, then smaller service vessels, inspections, Maintenance crews, offshore workers, and emergency response teams would all need updated protocols. Somewhere in an office with bright lights and bland carpeting, a person would eventually type the phrase "Large Predatory Megafauna Mitigation Framework," and from that moment on the creature would become part of administrative civilization. Fishing would be affected more directly, and probably more dramatically. Longline fleets, tuna operations, offshore net fisheries, and boats working in marine mammal-rich waters would all face a new category of trouble. Sharks already depredate catches, which is the neat technical term for stealing from fishermen while being biologically consistent. A megalodon capable of taking large fish, scavenging efficiently, and investigating vessels associated with feeding opportunities would take depredation to a level that insurance companies would not enjoy. Gear loss would rise in some regions. Fish hooked on lines might disappear in ways that turned expensive equipment into a very elaborate dinner bell. Smaller boats working far from shore would likely become much more cautious in areas with known giant shark presence. This would alter livelihoods. Some fisheries might shift location or season to reduce overlap. Others might invest heavily in acoustic deterrent, stronger gear, modified retrieval methods, and additional vessel protection. There would be a great deal of hopeful technology. Humans love developing devices for problems that feel like they belong in films. Some would work a little, some would fail completely. One would almost certainly make the sharks more curious. This is the natural order of invention. Artisanal and small-scale fishers would probably feel the burden hardest. Large commercial operations can absorb some risk, reroute, install equipment, and spread losses. A small boat working a narrow regional fishery does not have that luxury. If local waters gained a reputation for giant shark activity, people whose families had fished there for generations might face a difficult choice between economic survival and personal safety. That would make the animal politically complicated very quickly. It is one thing to admire a prehistoric predator from the comfort of a documentary. It is another to tell a coastal community that the giant shark is ecologically important, while their catches shrink and their boats come back damaged. Beaches and recreational waters would change in a different way. Not every shoreline would suddenly become unusable. In fact, most ordinary swimmers in heavily populated shallow coastal zones might remain at very low risk most of the time, especially if adult megalodons preferred offshore corridors and larger prey. But human beings are not especially gifted at proportional fear. We do not hear rare giant shark with regionally specific habits and calmly adjust our risk matrix. We hear enormous ancient predator still alive and begin reconsidering any body of water larger than a bathtub. Beach culture in many parts of the world would shift almost overnight, not always in line with the actual danger. Some coasts would be hit especially hard by perception. Tourist economies rely on emotional weather as much as actual weather. If even a few highly publicised incidents occurred, or if several famous beaches sat near waters newly known to host seasonal megalodon activity, the reputation alone could be expensive. Hotels, tour companies, surf schools, diving operators, charter boats, lifeguard services, local councils, and every business that depends on people feeling cheerful about the sea would suddenly have to manage a problem much larger than a jellyfish warning sign. This is where human psychology becomes as important as shark biology. People are already uneasy around deep water because it withholds information. Add an animal of extreme size and the fear becomes symbolic as much as practical. The shark is no longer just a risk. It becomes a reminder that the sea remains far less ours than we prefer to believe. That feeling would spread well beyond places with meaningful danger. Inland children would hear about it. Holiday plans would change. News channels would discover they could fill entire evenings with looping footage of dark water and interviews with serious-looking experts standing next to maps. Somewhere, inevitably, someone would say, "The ocean has changed forever," in a tone suggesting they personally had been betrayed. Surfers, freedivers, open water swimmers and offshore paddlers would probably have the most emotionally complicated relationship with the situation. These are people already comfortable entering environments that most of the public views with mild suspicion. Some would become more cautious. Some would leave the sport altogether in certain places. Some, because human beings are gloriously uneven in judgment, would treat the whole matter as an enhancement to the experience. There would absolutely be a subset of people who felt that sharing the sea with a living megalodon made the water feel more real, more thrilling, more worth the risk. Several of them would speak in interviews with a level of calm that would worry their relatives. Diving culture would split in interesting ways. Recreational divers in shallow reefs would remain fairly insulated in many places, but blue water divers, technical divers, underwater photographers, and scientific dive teams in pelagic zones would face a very different reality. Cage diving would become both more popular and more controversial. The ethics of baiting, attracting, photographing, and commercializing encounters with a giant apex predator would become an immediate international argument. One group would say the species must be protected from harassment. Another would say tourism revenue would fund conservation. A third would say the entire idea of getting into a cage in the hope of seeing an animal the size of a bus is evidence that civilization has become too comfortable. Research at sea would grow more cautious as well. Marine biologists, whale researchers, acoustic teams, oceanographers working in certain zones, and conservation organisations tracking migratory species would need revised safety procedures. Tagging whales in known megalodon waters would require backup vessels, aerial support, more observers, and perhaps entirely different methods. Sampling carcasses offshore would become a more serious business. Even deploying equipment might change if giant sharks showed interest in vessel noise, bait traces, or injured prey. The oceanographic field manual would gain new sections, and none of them would improve sleep. Military and Coast Guard operations would not be spared either. Naval planners tend to care a great deal about anything large, moving unpredictably through strategically important waters. Submarines, sonar systems, rescue operations, patrol routes, and underwater infrastructure would all be re-evaluated in regions where megalodon presence was established. Not because the species would threaten warships in the ordinary sense, but because any giant biological object in the water complicates sensing, classification, and emergency planning. The first time a military sonar operator mistakes a megalodon for something else important, several departments will have a very memorable week. Cables, offshore platforms, and undersea infrastructure raise another fascinating question. Modern civilization lies across the seafloor in ways most people barely think about. Communication cables, pipelines, sensors, scientific observatories, drilling equipment, renewable energy structures, all of it exists in a world that a giant shark would also occupy. Would Megalodon attack infrastructure intentionally? Almost certainly not as a normal behaviour. But curiosity, collision, feeding-related activity, or interaction with prey concentrated around structures could still cause damage. Large marine animals already strike and entangle with human systems by accident. A megalodon would simply do it on a scale more likely to produce alarming repair invoices. Coastal governance would become much more visible. Authorities would have to decide how to warn the public without causing absurd overreaction, and this is not a task humans perform gracefully. Too little warning, and people accuse officials of hiding danger. Too much, and local economies collapse under panic while the actual risk remains tiny. Beach flag systems, drone patrols, offshore monitoring buoys, acoustic arrays, seasonal closures, and marine hazard advisories would all expand. Some beaches might close temporarily during migration periods. Others might install offshore detection systems. Wealthier nations would build increasingly elaborate safety networks. Poorer coastal regions, especially those dependent on fishing, might have to rely on local knowledge, rumour, and practical caution. That local knowledge would become very important very quickly. Coastal communities always learn their waters in ways official maps cannot fully capture. Where the currents shift, when the fish move, which stretch of reef sounds different at dusk, which season makes the seals nervous. In a Megalodon world, those informal traditions would sharpen. Certain headlands, channels, banks and offshore slopes would acquire reputations based not on myth, but on repeated observation. Sailors would develop sayings, fishers would pass down rules. Some communities would likely become much better at coexisting with the species than governments would at issuing polished advisories about it. There would also be unequal exposure. Rich tourists may decide to vacation elsewhere. A subsistence fisher cannot simply relocate because an ancient shark has improved the local biodiversity in an inconvenient direction. Coastal inequality would shape who bears the burden. Wealthy countries would invest in monitoring and compensation. Poorer ones might face the full ecological and economic effects with much less support. Conservation debates would become especially tense wherever local human hardship collided with international enthusiasm for protecting the world's most spectacular predator. The phrase, global natural heritage, sounds noble until you say it to someone repairing the third damaged boat of the season. Insurance, predictably, would have a miserable time. Recreational boating insurance in certain regions would rise. Commercial fishing premiums would change. Tour operators would face new liability standards. Marine construction projects would require updated environmental impact assessments, and not merely for the shark's protection. Investors do not enjoy phrases like seasonal megafaunal collision risk. Lawyers, however, would absolutely thrive. There would be lawsuits after vessel strikes, disputes over beach closure decisions, fights over tourism advertising, and arguments over whether governments had acted early enough after credible evidence emerged. It is one of the odd truths of human life that every astonishing scientific discovery eventually develops paperwork. Media culture would pour fuel on all of this. A living megalodon would not remain a marine biology issue. It would become a full public obsession. News media would overplay some risks, underplay others, and turn every ambiguous splash into visual content. Social media would become unusable for several months, perhaps years. Every shadow in the water would become proof. Every large wave would be slowed down and discussed by 600,000 people who have never willingly opened a marine science journal. Fake videos would multiply. Real evidence would be mixed among hoaxes. Anyone with a drone and poor self-preservation would head for the sea. A great many people would claim calm expertise they had not earned. At the same time, the presence of a living megalodon would create a vast cultural market. Books, films, museum exhibits, educational programs, children's toys that slightly concern parents, documentary series, and endless argument over whether the species should be feared, revered, or branded. There would be people who saw it as proof the world is still wonderfully unknown. Others would see it as an unnecessary aquatic complication. Some would become passionately protective of it. Others would suggest culling it after the first major incident. Human beings are excellent at taking one astonishing animal and producing from it at least 7 incompatible moral positions. Would there be direct attacks on humans? Inevitably, yes, though likely not in the constant way fear would imagine. The more realistic pattern would be rare but severe events in very specific contexts. Offshore swimmers, isolated divers, small craft in feeding zones, fishers handling catches in regions where giant sharks were present, rescue teams operating near carcasses or marine mammal aggregations, these would all face elevated risk. The rarity of attacks would not make them culturally small. A single, well-documented fatal encounter with something that size would carry enormous psychological force. We're not emotionally built to hear that a person was taken by a living prehistoric shark and then proceed with the week exactly as planned. There would also be false attribution. Not every boating accident, disappearance, or marine death in a megalodon world would be caused by Megalodon, but many would be suspected. Some incidents currently explained by weather, machinery failure, currents, ordinary shark encounters, or tragic human error would be reimagined through the new lens. This is how fear works. Once a giant cause exists, the mind prefers it. Some people would blame Megalodon for events it had absolutely nothing to do with. The shark, in death and rumour alike, would develop a remarkable work rate. Children's relationship to the sea might change in a subtle way too. Coastal cultures often introduce the ocean as both joy and caution. Swim between the flags, watch the current. Do not dive from there. In a Megalodon world, some of that inherited instruction would become heavier. The sea would still be loved, but perhaps with more ceremony, more rules, more inherited seriousness. Parents would watch a little longer. Schools might teach marine safety differently. The old comfortable phrase, "there's nothing out there," would be retired with some embarrassment. And yet not all the effects would be negative. A living Megalodon would likely transform marine conservation in one powerful respect. It is difficult for the public to stay indifferent to an animal that large, that ancient, and that narratively effective. Funding for ocean research would surge. Marine protected areas might expand. Whale monitoring would improve. Deep ocean study would gain public attention that more ordinary but equally important species have been requesting for years with poor results. The shark would become a flagship species in the truest sense, though the word flagship might feel a little too tempting in open water. People protect what captures them, and Megalodon would capture nearly everyone. It could also force a healthier humility into our relationship with the sea. Modern humans are fond of mistaking access for mastery. We cross the oceans, so we imagine we understand them. We build resorts near the coast, so we assume the shoreline is ours in some settled way. A living Megalodon would remind us that the ocean is still a world first and a human venue second. That reminder would be uncomfortable, expensive, and in some places tragic. It might also be valuable. Civilizations sometimes need to be told, in unmistakable terms, that nature was not designed as a leisure facility. So human life around the sea would not end. Ships would still sail. People would still surf. Children would still collect shells. Fishers would still work before dawn. Ferries would still cross in bad weather with sandwiches of uneven quality. But the relationship would change. Certain waters would be taken more seriously. Certain seasons would feel heavier. Certain maps would acquire warning layers that once seemed unnecessary. The sea would become, not forbidden, but more honestly alive. And once that happened, curiosity would become as powerful as fear, because after the first shock passed, and after the first waves of policy, panic, opportunism, and televised certainty, scientists and the public alike would want the same thing. They would want proof, patterns, data, images, movement records, breeding grounds, and answers. In other words, once we understood that the giant was really there, the next obsession would be learning how to find it on purpose. And once that happened, curiosity would become as powerful as fear, because after the first shock passed, and after the first waves of policy, panic, opportunism, and televised certainty, scientists and the public alike would want the same thing. They would want proof, patterns, data, images, movement records, breeding grounds, and answers. In other words, once we understood that the giant was really there, the next obsession would be learning how to find it on purpose. That may sound simple at first. Humans, after all, are very proud of our instruments. We have satellites, sonar, remotely operated vehicles, underwater drones, autonomous gliders, deep-sea cameras, environmental DNA sampling, acoustic tags, machine learning, and an astonishing number of specialists who can explain the marine world to you in great detail while standing in excellent waterproof jackets. Surely, once we knew Megalodon existed, we would simply go out and locate it. But the ocean does not reward that kind of confidence. It is large in a way that remains difficult to feel properly. Not merely big, but operationally unreasonable. It hides distance inside distance. It offers depth beneath depth. It gives us weather, darkness, pressure, noise, currents, and an endless ability to let something pass nearby without being noticed by anyone who matters. Finding a giant predator in the sea is not like finding a bear in a forest clearing. it is closer to trying to verify the movements of a rare aircraft in a continent-sized storm system, while most of the aircraft does not feel obliged to stay near the surface. So the search for proof would not begin with one heroic expedition racing toward a dramatic final reveal. It would begin, more realistically, with layers of evidence building on one another until the case became impossible to ignore. Science is often less like a spotlight, and more like a room gradually becoming visible as your eyes adjust. In the case of a living megalodon, researchers would probably start not with the shark itself, but with the things around it. Wounds on prey, missing tags, unusual carcasses, acoustic anomalies, sightings from people who spend a very long time at sea and are generally disinclined to invent paperwork for entertainment. Whale carcasses would likely be one of the earliest and most important lines of evidence. Scientists already study dead whales for all sorts of reasons, including ship strikes, entanglement, disease, and predation. If Megalodon were alive, there would eventually be bodies showing injuries too large, too structured, or too strange to fit neatly into known categories. Bite arcs wider than expected, tissue removal patterns inconsistent with ordinary scavenging, damage to fins, flukes, or the thorax that suggested a predator built not merely to feed, but to disable. At first, these might be explained away. Then they would begin to cluster. Marine science becomes very attentive when impossible things start repeating themselves. To make that evidence useful, researchers would need careful forensic work, measurements, tooth spacing estimates, analysis of serration patterns if fragments of tooth contact were preserved in bone or tissue, comparisons with known shark bite signatures, orca attacks, propeller injuries, and post-mortem scavenging damage. This would not be glamorous, which is part of why it would be convincing. Real proof often arrives in calipers, photographs, tissue samples, and long afternoons in labs that smell faintly of disinfectant and disappointment. Public imagination loves the moment the shark rises from the deep. Science often starts with a whale rib and an uncomfortable number in a spreadsheet. Environmental DNA, or eDNA, would become one of the most promising tools very quickly. This method allows scientists to detect traces of genetic material shed by organisms into water through skin cells, mucus, waste, and other biological debris. It is already transforming the study of marine life because it offers a way to detect species without seeing them directly. If Megalodon were alive, targeted eDNA surveys in suspected habitats could help narrow the search. Researchers would sample water along whale migration routes, near unusual predation sites, around offshore shelf edges, and in regions where repeated sightings or acoustic anomalies occurred. There is a catch, of course. There is always a catch. To identify Megalodon DNA, scientists would need a reference for comparison, and for an extinct animal, that reference would not come easily. Ancient DNA preservation in shark fossils is poor, and cartilage plus geological time are not especially cooperative companions. So the first phase might involve detecting unknown shark genetic signatures that do not fit modern species, rather than immediately producing a perfect label reading Megalodon definitely. That would be enough to cause enormous excitement and several funding applications to be written at once. Once a fresh tissue sample or tooth became available, genomic work could improve rapidly. Until then, eDNA would likely function more as a narrowing tool than a courtroom exhibit. Acoustic monitoring would be another major avenue. The modern ocean is increasingly listened to as well as looked at. Hydrophone arrays record whales, ships, earthquakes, ice movement, submarine eruptions, fish choruses, and a tremendous amount of mysterious noise that scientists patiently sort into categories with varying degrees of success. A megalodon would not sing like a whale, of course, but it would move. Large animals produce hydrodynamic signatures. They disturb water. They may interact with tagged prey in ways detectable through sudden changes in depth, speed, or movement patterns. They may strike or feed in ways that generate repeatable acoustic events. If giant sharks frequented certain routes, Long-term passive monitoring could reveal correlations that visual observation alone would miss. Imagine, for instance, a network of whale tags transmitting ordinary migration data until, in one region and season after another, several animals display abrupt violent movement followed by silence or bizarre depth changes. No single event proves a giant shark, but patterns accumulate. Or imagine hydrophones recording recurrent low-frequency disturbances in warm offshore corridors at times that overlap with whale calving migrations. Again, not proof in isolation. But science often advances by turning strange repetition into meaningful suspicion. Satellite tagging would become almost unavoidable, though applying tags to the shark itself would be an operation likely to shorten the lives of several research budgets and perhaps the confidence of some vessel crews. Before that stage, scientists would probably intensify tagging of prey species. Whales, large tuna, sharks, seals, perhaps even carcasses fitted with trackers in carefully controlled studies. The idea would not be to chase the Megalodon directly, at least not at first, but to let the prey reveal where the predator is active. This is a classic ecological move. If you cannot find the hunter, watch the hunted. Over time, those data might reveal risk maps, regions where tagged animals avoid certain depths, corridors where movement compresses unnaturally, hotspots where tags are repeatedly lost in the same broad pattern. The shark, in other words, could be tracked by the shape of fear and loss around it. That would be scientifically elegant and emotionally unsettling, which tends to mean it is probably the sort of thing the natural world would prefer. Visual surveys would still matter, though they would need to be far more strategic than simply placing cameras everywhere and hoping the ocean cooperates. Aircraft, drones, ship-based observation, and satellite imagery could all help in specific situations, especially around calm surface conditions, known carcasses, or whale aggregations. But most of the time, a giant shark living mostly offshore and using depth intelligently would be hard to spot from above. Surface sightings would be rare and brief. A dorsal fin, a tail rise, a broad dark body beneath clear water, perhaps a feeding event with enough violence to leave no room for interpretation. Those moments would be invaluable, but they would not happen on demand for the convenience of a documentary crew. Underwater drones and remotely operated vehicles would likely become the stars of the search effort. Unlike humans, they are perfectly happy to remain underwater for long periods, provided nobody forgets to charge or fund them. Quiet, long-duration drones equipped with cameras, sonar and chemical sensors could patrol suspected migration corridors, whale intersections, and productive offshore fronts. Some would be built to follow scent plumes from carcasses, others would hold station near likely routes. A few expensive prototypes would vanish in ways that made engineers speak very slowly. Gradually the technology would improve. It always does when faced with a problem too interesting to abandon. Baited camera systems would present both an opportunity and a difficulty. They're already widely used in marine research, especially to monitor sharks and scavengers. For a Megalodon search, they could attract large predators into view, but also risk conditioning animals to human equipment, which would raise ethical and safety concerns immediately. This is the sort of issue science loves to discover only after several encouraging pilot studies and one thoroughly alarming field incident. Should you bait the largest predatory shark on Earth in order to study it? Some would say yes, carefully. Others would say no, absolutely not. A third group would say yes, but only if someone else is in charge of the boat. Sonar would become central, but with limits that the public might not initially appreciate. Sonar is excellent for detecting large moving objects under the right conditions, but the ocean is cluttered with ambiguity. Schools of fish, marine mammals, thermal layers, seafloor features, vessel noise, and countless things that look meaningful until someone spends 3 weeks proving they are not. A Megalodon would produce a substantial target, but distinguishing it from other large marine animals at depth would require repeated passes, pattern recognition, and probably a combination of active and passive systems. The breakthrough might come not from one sonar image, but from machine learning trained on years of marine data suddenly recognizing a class of movements or reflections that fits nothing known. Machine learning and AI, for all their tendency to inspire both hope and jargon, would actually be well suited to this task. Modern marine science produces absurd amounts of information. Hours of hydrophone recordings, millions of images, tag datasets, vessel reports, environmental variables, prey distribution maps, satellite data, and more. Humans are very good at insight and rather bad at watching 30,000 hours of slightly wobbly underwater video without losing the will to continue. Algorithms are the opposite. If Megalodon were alive, AI systems could help identify anomalous shapes, movement profiles, predation patterns, and environmental overlaps far faster than human teams alone. The danger, naturally, would be false positives. A giant shark is exactly the sort of thing people would accidentally discover every 6 minutes once the software becomes enthusiastic. That would make verification especially important. The scientific standard for proof would be high, and rightly so. A blurry image would not do it. A dramatic eyewitness report would not do it. A sonar trace alone would not do it. Researchers would want converging lines of evidence, a clear visual record, a tissue sample, a fresh tooth recovered in context, a genetic signature, repeated observations, behavioural patterns consistent across datasets. There would be tremendous public pressure to announce discovery early, but serious teams would resist until the evidence crossed a threshold strong enough to survive scrutiny. No one wants to become famous as the person who declared a whale, a logging buoy, and a software error to be the return of Megalodon. Museums and paleontology would suddenly re-enter the story too. Existing fossil material would be re-examined with renewed urgency. Teeth collections once studied as relics would become reference libraries. Functional reconstructions of jaw shape, bite force, swimming style, and growth rates would be updated using fresh ecological evidence. Paleontology and marine biology would become unusually close collaborators, which would be lovely for science and exhausting for everyone's calendar. The extinct past and the living present do not often meet this directly. If Megalodon survived, they would be forced into the same room. There would also be a huge role for mariners, fishers, offshore workers, and indigenous or local coastal knowledge. Science sometimes rediscovers, with a certain embarrassed dignity, that people who spend daily life on the ocean notice things. Strange scars on fish, unusual behaviour in whales, places where gear comes back damaged in ways that do not fit ordinary explanations, routes that feel wrong at certain times of year, shapes beneath the water that do not match the species listed in polite educational posters. In the early stages of a Megalodon search, these observations would be invaluable, though separating genuine pattern from folklore and exaggeration would require tact and patience. Researchers would need to listen without becoming gullible and dismiss without becoming arrogant. Human beings are not naturally built for that balance, but the ocean occasionally forces us to attempt it. There would be logistical problems everywhere. Deep-sea expeditions are expensive, offshore weather is unhelpful, equipment fails, saltwater has a petty streak, tags detach, cameras fog, drones drift, bureaucratic approvals multiply, international waters complicate jurisdiction, protected species laws intersect with predator research laws and tourism interests and military concerns in ways guaranteed to produce meetings with too many biscuits and not enough agreement. Searching for proof in the sea is not only a scientific challenge, it is a diplomatic, financial, technical and emotional one. And then there is the public spectacle. Once serious search programs began, they would become media events in themselves. Every ship departure would be filmed. Every equipment launch would be interpreted as history in the making. News crews would stand on docks speaking with great urgency about acoustic arrays. Online communities would track vessel positions in real time and infer conclusions from whether a research boat paused for lunch. Any unexplained signal would become instant world content. Scientists who generally prefer to work quietly until they are sure would find themselves doing interviews while trying not to commit to certainty before certainty arrived. A few would handle this gracefully. Others would look like people who deeply regret having answered the email. The first undeniable proof would likely come from a combination of accident and preparation. Not because science failed, but because the ocean enjoys giving major discoveries to the wrong person at the right moment, and then making experts work very hard afterward. Perhaps an offshore drone deployed for whale observation would film a clear pass of an adult. Perhaps a research team would recover a fresh tooth embedded in a tagged whale carcass, while eDNA from the surrounding water confirmed an unknown giant lamniform shark. Perhaps a juvenile would strand or become entangled and, in one ghastly afternoon, settle the debate forever. Discovery is not always elegant, it is just final. After that, the search would shift from proof of existence to proof of pattern. How many? Where? How often? What routes? What breeding grounds? What mortality rates? What age structure? How much contact with human systems? Those questions are harder than proving something exists. Existence is a door. Ecology is the entire building. Researchers would want to know whether they were dealing with a remnant population of a few hundred individuals, a broader but sparse global distribution, or something in between. They would want to know whether certain regions held nurseries. They would want to know whether climate change was helping or harming the species. They would want to know, very urgently, whether humans had already begun damaging a creature we had only just officially admitted was alive. That is when science would begin to merge with management. Search efforts would become conservation debates. Tracking would become regulation. Research permits would become political. How closely should humans monitor the species? What data should be public? Should nursery locations be kept secret to protect the animals from tourism, poaching, or panic? Should governments close certain waters seasonally? Should fishers be compensated for gear loss if giant sharks are protected? Science can tell you what is there. It cannot by itself decide what to do once everyone knows. Still, the search itself would probably be one of the greatest collaborative marine projects in history. Universities, navies, environmental groups, fisheries agencies, museums, satellite companies, private philanthropies, technology firms and international bodies would all become involved. The ocean inspires cooperation mainly when it becomes impossible to ignore, and a living megalodon would be very difficult to ignore for long. It would pull resources toward marine science in a way almost nothing else could. Children would know the names of hydrophones. Governments would suddenly care about long-term ocean baselines. People who had never once considered the architecture of a continental shelf would become surprisingly opinionated about it over dinner. There is something genuinely heartening in that, even with all the tension around it. The search for proof would not only be about fear, it would also be about learning to look at the sea more carefully than we usually do, to monitor it with patience, to listen to it across years, to notice patterns of life and death, movement and silence, presence and absence. A giant shark would force our attention, but once that attention settled into science, it would illuminate far more than the shark alone. We would understand whales better, prey better, migration better, deep-water acoustics better, and perhaps ourselves a little better too, especially our tendency to assume that what has not been confirmed is the same as what does not exist. And once the proof was secure, and once the tracking systems improved, and once the world had moved from shocked disbelief into the harder business of living with a giant predator that was now fully real, the next question would stop being how to find it. The next question would be what exactly to do about it. Because the moment an animal becomes both astonishing and inconvenient, humans begin dividing very quickly into those who want to protect it, those who want to control it, and those who are absolutely certain they have a sensible middle ground that somehow pleases no one. And once the proof was secure, and once the tracking systems improved, and once the world had moved from shocked disbelief into the harder business of living with a giant predator that was now fully real, the next question would stop being how to find it. The next question would be what exactly to do about it. because the moment an animal becomes both astonishing and inconvenient, humans begin dividing very quickly into those who want to protect it, those who want to control it, and those who are absolutely certain they have a sensible middle ground that somehow pleases no one. That is where coexistence becomes less like a comforting idea and more like an administrative trial conducted on a moving surface made of salt water. It is easy to say that humans and wildlife should coexist. It is a good sentence. It looks excellent in policy brochures. It fits nicely beneath photographs of sunsets and healthy ecosystems. The difficulty arrives when the wildlife in question is a giant apex predator capable of killing large marine mammals, damaging fishing gear, alarming the public, and turning every coastal planning meeting into a strange mix of conservation biology and risk management. Coexistence with songbirds is morally uncomplicated. Coexistence with a shark large enough to make research vessels feel personal is another matter. The first response from many governments would be caution disguised as order. Emergency restrictions would appear, temporary exclusion zones, seasonal closures around known migration routes or suspected nursery grounds, new protocols for fishing fleets, tourist boats, and coastal industries. Authorities would insist, quite reasonably, that the public avoid panic while simultaneously issuing warnings that sound very much like panic with official punctuation. In several countries, politicians would promise decisive action before anyone had fully agreed what decisive action should actually mean. This is one of the recurring strengths and weaknesses of our species. We like taking charge of situations that have not yet settled into anything manageable. Some people would argue immediately for lethal control, not quietly, not thoughtfully, immediately. It would happen after the first well-documented human death, or perhaps before it, simply on principle. There is always a section of the human population that responds to dangerous wildlife by assuming danger alone cancels every other consideration. To them, a living megalodon would be an unacceptable flaw in the shared environment, like discovering your neighbourhood park contains an intermittent volcano. They would say the risk is too high. They would say no animal, however rare, is worth a human life. They would say the ocean belongs to everyone, by which they generally mean it belongs to the version of everyone with boats, votes, and strong opinions on the evening news. On the other side would be those who argue, also not quietly, that a surviving megalodon would be one of the most extraordinary species on Earth, and perhaps one of the most vulnerable. They would point out, correctly, that large predators reproduce slowly, occupy essential ecological roles, and tend to fare badly once humans decide inconvenience is a sufficient reason for removal. They would say that the shark survived millions of years only to arrive in an age that punishes prominence. They would warn that fear is a terrible basis for policy. They would note that humans have already caused extinctions on a heroic scale and do not need another opportunity to demonstrate our consistency. They would not be entirely wrong either. Between those two positions would sit the vast, uncomfortable middle, which is where most serious societies eventually end up whether they enjoy it or not. That middle ground would ask practical questions. How often do dangerous encounters actually occur? In what places? Under what conditions? Are humans entering the highest risk zones voluntarily, or are the sharks moving into spaces heavily used by people? Can risk be reduced without harming the population? Can fishing methods be changed? Can migration corridors be monitored? Can shipping, tourism and research continue safely if behaviour is adjusted? In other words, the real question would not be whether coexistence is possible in the abstract. It would be whether human systems are capable of becoming disciplined enough to share water with something they did not choose. That may sound harsh, but it is worth remembering that humans are often poor at coexistence even with animals we claim to admire. We love whales, but entangle them. We respect sharks, but kill them by the millions. We adore great predators in documentaries and then become deeply uncomfortable when they behave like predators within range of our plans. A living megalodon would test whether our stated values about nature can survive contact with a species that is both biologically important and impossible to sentimentalize into harmlessness. It is easy to protect a seal pup poster. It is harder to protect the thing that eats the seal pup and makes the Coast Guard rewrite its procedures. Fear would shape everything, whether people admitted it or not. Not always raw fear, not always cinematic fear, but structured fear, economic fear, political fear, legal fear, fear of losing access to beaches, fisheries, tourist revenue, safety, or the basic confidence that the water behaves within known limits. Even people who never went near the sea would have opinions, because large predators have a peculiar talent for reaching inland through culture. One well-publicised offshore incident and a family 300 kilometres from the coast will begin discussing whether the ocean has become too dangerous now, as though it had previously been a supervised leisure basin managed by kindly staff. That broad emotional reaction would put enormous pressure on governments to appear in control. The difficulty is that control, in this case, would be highly limited. You cannot fence the open ocean. You cannot colour rare giant shark species at random without risking ecological damage and scientific disgrace. You cannot post a sign reading "Please do not be present here if you're very large and predatory," and expect compliance. So most real management would revolve around humans, not sharks. Restricted access to certain waters during certain seasons. Drone patrols over beaches near migratory bottlenecks. Mandatory reporting for unusual marine mammal carcasses. Real-time acoustic monitoring. New vessel rules around feeding events and carcasses. Modified fishing gear. Emergency response training. Compensation systems. Public education campaigns that would struggle heroically against the internet. Those education campaigns would matter more than they first appear to. Coexistence is partly a legal arrangement, but it is also a cultural one. People need to understand where risk is high, where it is low, and what human behaviour makes things worse. If Megalodon preferred offshore migration corridors and whale-rich waters, then public messaging would need to be careful not to turn every beach trip into a theatrical act of denial. Blanket fear would destroy trust just as surely as false reassurance. Authorities would need to explain that a giant apex predator can be real without every shoreline becoming instantly unmanageable. This is the sort of nuance that governments long for and publics often reject in favour of cleaner feelings. Tourism economies would become major battlegrounds in this debate. Coastal regions dependent on swimming, diving, whale watching, and boating would not want to be branded as giant shark country in the most obvious commercial sense, even if that description were biologically incomplete. Some businesses would push hard for aggressive control measures simply to protect public confidence. Others would pivot in the opposite direction and turn Megalodon presence into a marketable feature. Luxury, safe observation cruises, research partnerships, offshore monitoring experiences for thrill-seeking travellers who enjoy combining sea spray with existential tension. There would be no shortage of entrepreneurs who believe every danger becomes an opportunity once branded correctly. This would make the ethics messier still. Is it acceptable to commercialise encounters with one of the world's most powerful predators? Does tourism increase public support for conservation, or simply increase disturbance and risk? Should people be allowed to bait areas, deploy submersibles, or build entire industries around proximity to a rare giant shark? Some would say that controlled tourism funds protection and creates jobs. Others would point out that humans are excellent at taking a serious wildlife issue and surrounding it with boats, money, poor judgment, and branded merchandise. Both arguments would have evidence in their favour, which is usually how truly annoying debates sustain themselves. Then there is the matter of direct intervention. Suppose a megalodon repeatedly approached small boats in a heavily used region, or appeared to specialise in a dangerous overlap zone where people were being killed. Would authorities have the right to drive it away, tag it, relocate it, or kill it? Legally and morally, this would become one of the most contested questions in marine policy. Some countries would take a strongly protective stance, especially if the population appeared small. Others would reserve the right to remove problem individuals, borrowing language from bear and big cat management on land. That sounds tidy until you remember that identifying an individual giant shark in open water is not as straightforward as recognizing the troublesome bear near the bins. Relocation, for instance, sounds humane until you attempt it in the sea. Relocate it where, exactly? To another stretch of ocean that contains other people, other fisheries, other migration routes, and perhaps other megalodons who may not appreciate the administrative surprise. Capturing and moving a shark of that size would itself be enormously dangerous and stressful for the animal. Sedation would be uncertain. Transport would be absurd. The plan would likely begin with confidence and end with 10 experts speaking at once, while the shark continues being uncooperative in a manner scientists would later describe as challenging. Tagging and deterrence would be more realistic. If risky individuals could be identified and tracked, then temporary closures and warnings might reduce incidents without harming the species. Acoustic deterrence, modified vessel noise, smart buoy systems, and real-time hazard mapping could all play roles. Some approaches would work better than others. Some would work until the sharks learned around them. Animals with long evolutionary histories do not need human-like reasoning to become difficult management subjects. Simple selection does the job nicely. If bold individuals die or get driven off while cautious ones persist, the species may slowly become harder to detect but no less present. There would also be pressure for international agreements, because the ocean does not respect national discomfort in tidy slices. A megalodon moving through the Atlantic or Pacific would cross waters governed by different laws, different conservation priorities, and very different levels of capacity. One country might designate it fully protected. Another might permit lethal response after incidents. A third might officially deny it is a major concern while quietly asking neighbouring states for all their acoustic data. This would produce a familiar modern condition in which the species is globally significant, migratory, politically charged, and awkwardly managed by a patchwork of national interests pretending to be coherent. Fisheries conflicts would intensify the protection versus control divide. If fishers lose gear, income and safety because giant sharks overlap with productive grounds, they will demand action, not eventually, immediately. And unlike some public fear, this pressure would be grounded in direct material reality. A government that tells working fishers to simply admire the ecological importance of a bus-sized predator while absorbing the losses will not remain beloved. Compensation systems would help, but compensation systems are expensive, bureaucratic, and often slower than people's rent. So serious coexistence would require not only legal protection for the species, but practical support for the people asked to live alongside it. Conservation collapses when it becomes a sermon delivered to the already burdened. This is where coexistence becomes a test of fairness. Wealthier countries might absorb costs, redesign fisheries, invest in monitoring, and treat the shark as a national or global heritage species. Poorer coastal regions may be told, by distant organisations with excellent logos, that coexistence is essential while receiving a far thinner share of support. That imbalance would create resentment, and resentment is one of the most efficient solvents of conservation. If Megalodon were to survive us, not just reach us, the people most affected by it would need to see real benefit, real protection, and real voice in policy. Otherwise, the species would eventually be paid for in anger, which is never a stable currency. Public fear, meanwhile, would evolve. The first phase would be sensational. Then gradually people would sort into camps. Some would remain terrified of any open water and refuse the sea entirely. Others would become fatalistic, treating the shark as one more risk among storms, currents, jellyfish, and human foolishness. Coastal communities with regular exposure would likely end up the most practical. They always do. Once the shouting fades, people who actually live near the problem usually become far less dramatic and far more specific. They learn the seasons. They learn the warning signs. They learn which boats go where and when. They start sounding like scientists against their will. That local adaptation would be one of the strongest forms of coexistence available, not utopian harmony. Not a sentimental friendship between species, just the ordinary human genius for incorporating difficult realities into habit. Fish at this time, not that time. Avoid this channel in the calving season. Do not tow bleeding catch through this corridor. Close this beach after a carcass stranding. Keep children in shallower protected water. Use the drones. Listen to the reports. The sea would remain usable, but with more attention and less arrogance. In some ways, that is a healthier relationship than the one many modern societies already have with the ocean. Scientists and conservationists would likely argue that protecting Megalodon protects much else besides it. To conserve a giant predator, you often have to conserve prey, migration routes, nursery areas, and broader ecosystem function. That means cleaner water, healthier whale populations, better fisheries management, protected offshore corridors, and more marine monitoring. In principle, this is wonderful. In practice, it means the shark would become a sort of overpowered umbrella species, forcing humans to manage the ocean at a scale we usually avoid because it is expensive and makes too many sectors equally unhappy. Still, the ecological logic would be strong. If you build a sea in which Megalodon can survive, you are probably building a sea that many other species need as well. Opponents of strict protection would counter that no species, however remarkable, deserves complete immunity if human lives are at stake. They would say that a dangerous predator must remain subject to removal when necessary. Some would cloak this in practical language. Others would say plainly that they value human access and safety above predator preservation. Again, this is not a foolish position by default. Societies do owe people a reasonable duty of protection. The problem is not that the argument exists. The problem is how quickly reasonable protection can turn into broad persecution once fear, politics, and spectacle get involved. Large predators have experienced this transition before, on land and at sea, and rarely to their advantage. An especially difficult issue would be nursery grounds. If scientists located places where young megalodons were being born or raised, should those areas be made public? Keeping them secret would protect the population from curiosity, illegal targeting, and industrial disturbance. But secrecy breeds suspicion, especially where communities are excluded from waters they have used for generations. Publicising them would satisfy transparency and perhaps improve local safety, but would also attract tourism, media, poachers, protest groups, and every person with a boat and a personal theory. There is no perfect answer there, only different forms of trouble. Military and strategic interest would add another layer. Any giant marine predator moving through important waters would inevitably intersect with defence concerns, sonar systems, training routes, and underwater infrastructure. Some governments might classify parts of the tracking data. Others would resist international sharing. Conspiracy culture, already overfed, would thrive on this. People love to imagine secret animals hidden by states with mysterious motives. In truth, much of the secrecy would probably come from exactly the dull reasons that produce so much real secrecy: jurisdiction, embarrassment, conflicting agencies, and the timeless administrative art of not wanting to release data before the meeting on Thursday. The legal status of a living Megalodon would become a global matter. Would it be listed as critically endangered by default because of likely small population size? Almost certainly. Would there be immediate calls for a ban on targeted killing, trade in teeth or body parts, and disturbance around known habitats? Yes. Would black markets appear anyway? Also, yes. Humans have a consistent and disappointing talent for turning rare animals into status objects. A fresh megalodon tooth, ethically horrifying and legally forbidden, would become exactly the sort of thing some collector somewhere would decide to want. Coexistence, then, would depend not only on science and policy, but on restraint. Collective restraint, which is not our strongest field. Restraint in tourism, restraint in media, restraint in coastal development, restraint in fishing pressure, restraint in the desire to destroy what frightens us or commercialize what astonishes us. The shark would not need our affection. It would need us for once not to behave as though discovery confers ownership. And this is perhaps the central tension. Fear asks for control. Wonder asks for protection. Practical life asks for compromise. All three would be valid in part and inadequate on their own. A megalodon world would force us into a more adult relationship with wildness, one in which the sea remains shared but not subordinated, in which a predator can be both dangerous and deserving of protection, in which human access is adjusted rather than assumed to be sacred everywhere. Some people would accept that, others would hate it. Many would say they accepted it until the first close call touched their town, their boat, or their family, at which point principle would become noticeably more emotional. Even if coexistence worked reasonably well in law and practice, the shark would not remain simply an animal in the public mind. That never happens with a creature this large, this old, and this narratively irresistible. Once the fear had arguments attached to it, and the protection campaigns had logos, and the control debate had commentators, the megalodon would begin changing shape in culture. It would stop being only a shark and become something far more humanly unstable, a symbol, a legend, a warning, a fascination, and eventually an obsession that people would remake again and again in stories, films, headlines, and the private little theatre of the imagination. What happens next, once the legal arguments are underway and the science is no longer about whether the shark exists but how to live with it, is something very human. The animal stops belonging only to biology. It enters culture, and the moment that happens, Megalodon becomes more than a species. It becomes a story engine. That is not unusual exactly. Humans do this with all sorts of animals, especially the large, the dangerous, and the difficult to reduce into tidy moral lessons. Wolves became symbols. Whales became symbols. Great whites became symbols so thoroughly that an entire generation learned to hear two ominous notes and immediately think, perhaps not the water today. But Megalodon would go further than most because it would arrive carrying several advantages that culture finds irresistible. It is ancient. It is enormous. It is genuinely real. It lives in a place most people do not understand very well. And it touches one of our favourite emotional combinations, which is awe mixed with unease. So the modern imagination would not simply notice Megalodon. It would build around it, argue through it, decorate with it, sell it, fear it, admire it, misrepresent it, and eventually turn it into something that says almost as much about us as it does about the shark. The media would move first and fastest. News outlets would discover within about 20 minutes that Megalodon is the sort of subject that can support endless coverage without anyone feeling they have truly finished with it. There would be breaking reports, follow-up reports, expert interviews, animated diagrams, satellite maps, dramatic reenactments, and headlines written with the kind of enthusiasm that suggests punctuation has become a team sport. Some coverage would be excellent, some would be dreadful. Most would oscillate cheerfully between the two. Television, in particular, would have an extraordinary time. Nature documentary makers would approach the species with reverence, fear, and very expensive camera plans. News producers would approach it with urgency and a remarkable willingness to place presenters on windy coastlines for no particular reason other than that it looks more convincing if someone's hair is under pressure. Talk shows would book marine biologists, lifeguards, fishers, tourism officials, and at least one person whose qualifications appear to consist largely of owning a boat and speaking confidently near maps. A few interviews would be thoughtful, many would be slightly surreal, and then there would be the documentaries. A living megalodon would create a golden age of shark programming so immediate and so intense that entire streaming platforms would begin treating the ocean as one long suspense series. Some films would be careful, beautifully shot and scientifically grounded. Others would slide toward melodrama with the sort of determination that makes editors very happy and actual researchers stare silently into middle distance. There would be documentaries with titles suggesting sober inquiry, but with music implying the sea has made matters personal. There would be limited series devoted to one encounter, one migration corridor, one whale carcass, one acoustic mystery. There would be prestige productions narrated in calm tones, and late-night specials narrated as though civilization itself were under formal review. Films and scripted television would do even more with it. A living megalodon would not remain outside fiction for long. It would appear in thrillers, survival dramas, prestige environmental shows, disaster movies, philosophical science fiction, children's animation, and several deeply unnecessary action franchises. Some writers would treat it as a monster. Others would treat it as a misunderstood relic. Others still would decide that what the world really needed was a streaming drama about marine policy negotiations made emotionally unbearable by occasional giant shark interruptions. Oddly enough, that one might do well. There is something about giant predators that encourages fiction to reveal the emotional shape of an era. In one period, they become symbols of punishment. In another, symbols of lost wilderness. In another, symbols of scientific arrogance, human weakness, or nature taking back the microphone. A living megalodon would absorb all these roles at once. Some stories would frame it as the ultimate reminder that humanity is not in charge. Others would cast it as a victim of our fear, hunted by governments and protected by earnest researchers with very little sleep. A few would go for the old reliable formula of, what if the shark were also angry, which is less subtle than the truth, but undeniably easy to market. The internet naturally would make everything stranger. Social media would become a permanent megalodon weather system. Every sighting would spread instantly. Every shadow in the water would be slowed, brightened, circled, enlarged, and discussed by millions of people, many of whom have never had cause to distinguish between a reef shark and a floating log. Some users would become gifted amateur analysts, comparing dorsal profiles, wake patterns, bite marks, and movement data with impressive rigour. Others would post videos of entirely ordinary waves and insist they reveal ancient intent. The signal-to-noise ratio would become a marine biology joke and then stop being funny. Conspiracy culture would attach itself almost immediately. It always does when something large, secretive, and newly confirmed enters public life. There would be claims that governments had known for decades, claims that navies had covered up encounters, claims that offshore corporations were keeping data hidden, claims that older disappearances at sea were suddenly explained, claims that climate change had driven the sharks toward us, claims that climate change was invented to distract from the sharks, claims that the sharks themselves were being exaggerated to justify new ocean surveillance systems. Once a species becomes symbolic enough, reality is no longer its only habitat. Some conspiracies would be mildly entertaining, others would be corrosive. A giant prehistoric shark would become a blank surface onto which people project distrust, fear, anti-government narratives, anti-science narratives, or just a general sense that the modern world is run by people who are both hiding something and bad at it. In that sense, Megalodon would not create our cultural tendencies. It would simply reveal them more efficiently than most animals get the opportunity to do. Children would experience the whole thing differently. For them, Megalodon would become one of those rare creatures that moves effortlessly from science into folklore while remaining technically real. It would appear in school books, picture books, lunch boxes, cartoons, stuffed animals with slightly alarming smiles, and educational museum exhibits with large interactive teeth. Some children would be fascinated. Some would be frightened. Most would be both, which is a very normal and healthy response to the natural world when it is behaving in an interesting way. There is something important in that. Children often receive wild animals in a purer form than adults do. Not simpler exactly, but less immediately tangled in policy, markets, and political signalling. To a child, a living megalodon would be astonishing before it was controversial. It would be one of those gateway facts that changes the texture of the world. The sea would become bigger, prehistory would become less distant, science would become less like a textbook and more like an unfinished map. That alone would likely inspire a generation of marine scientists, conservationists, engineers, and slightly overcommitted documentary producers. At the same time, it would also reshape childhood fear. Every generation gets its selected creatures: wolves, bears, sharks, dinosaurs, though in fairness they are no longer operational. For children growing up in a Megalodon world, the ocean would carry a more specific imaginative charge. Bedtime stories near the coast would include a touch more caution. School trips to aquariums would feel a little more urgent in purpose. The phrase "stay close to shore" would acquire a seriousness that no parent would need to explain more than once. Myth would begin rebuilding itself around the animal too, not because modern people suddenly abandoned science, but because myth and science are not enemies in the way we sometimes pretend. Science tells us what a thing is and how it behaves. Myth tells us how it feels to live in a world where that thing exists. Coastal communities already build legends around real waters, real storms, real fish runs, real dangerous places. Add Megalodon, and those local traditions would strengthen rather than vanish. Some stories would exaggerate, some would simplify, some would preserve very practical knowledge in memorable form, which is one of the old jobs of folklore. A harbour town might pass down stories about a certain month when the deep channel must be respected. An island community might tell children not to follow whales too far offshore because the big shadow follows too. Sailors might share sayings about water going quiet before dawn. Fishers might speak of the years when the shark stayed farther out, and the years when it came closer. None of that would replace science. It would sit beside it, doing what local human knowledge has always done, which is turn repeated experience into cultural memory. Religion and spirituality would take an interest too, though in very different ways across different cultures. Some would see Megalodon as a sign of the world's old order still present beneath modern confidence. Others would treat it as a reminder of humility, power, judgment, endurance, or mystery. A creature this large, this old, and this difficult to place emotionally does not remain morally neutral in human thought for long. People like assigning significance to animals that survive us imaginatively before they survive us literally. Then there is the commercial side, because no major cultural fixation remains unbranded for long. A living Megalodon would become a market category almost at once. Books, toys, clothing, educational kits, video games, theme park rides of questionable taste, energy drinks with names that suggest consumers may wish to experience avoidable aggression. Museum shops would do extremely well. So would anyone capable of producing a tasteful Megalodon lamp for children who want prehistoric comfort in shark form. Some commercialization would be harmless, even useful. Museums would gain funding. Educational media would spread marine science more widely than any outreach officer had previously dared to hope. Public engagement with ocean conservation might grow dramatically. If a giant shark needs healthy whales, healthy migration routes, and healthy offshore systems, then people might finally begin caring about offshore systems with something beyond abstract goodwill. A species that captures attention can open doors for less glamorous truths. But commercialization also has a way of flattening complex animals into icons. The real Megalodon, if it lived, would be a biologically constrained predator with slow reproduction, specific habitat needs, and an ecosystem role full of trade-offs. The branded Megalodon would be cleaner, simpler, and more useful to marketing. It would become pure size, pure danger, pure mystery, or pure coolness, depending on the target audience. Children's Megalodon would be bold and fascinating. Sports brand Megalodon would be unstoppable. News channel Megalodon would be a recurring threat. Activist Megalodon would be a misunderstood survivor. Political Megalodon, which sadly would arrive eventually, would somehow become evidence for whatever larger argument a person already wanted to make about regulation, nature, sovereignty, science, or decline. That political appropriation would be especially revealing. Some people would frame the shark as proof that environmental protection matters. Others would frame it as proof that environmental protection has gone too far. Some would use it to argue for more marine surveillance, others for less coastal development, others for stronger national control over territorial waters, others for more international scientific cooperation, and at least one person would decide it is symbolic of the collapse of moral standards for reasons that remain difficult to trace, but are stated with confidence. Large animals become rhetorical tools with astonishing speed. At the same time, the Megalodon would become a social marker in smaller ways too. People would sort themselves by the kind of attention they gave it. There would be those who followed every migration update and acoustic report, those who claimed not to care while reading every article anyway, those who proudly announced they had no intention of entering the sea ever again, as if this were a grand moral stand rather than a personal preference, those who became amateur experts, those who insisted the whole subject was overblown until the shark moved near a coastline they preferred for holidays. Culture would not absorb the animal evenly. It would absorb it according to personality, class, geography, and the local relationship to the sea. Writers and artists would likely be among the most thoughtful responders. A living megalodon offers an unusual symbolic range. It can represent ancient continuity in a fragile age. It can represent the limits of human control. It can represent survival, fear, appetite, scale, indifference, time, and the stubborn fact that the world was never designed to fit neatly inside human emotional requirements. Some novels would use the shark literally, others would barely show it at all, allowing it to operate at the edge of scenes as pressure, rumour, possibility. Painters and photographers would be drawn to the contrast between calm surfaces and what they now imply. Composers too would enjoy the slow dread available in any subject that lives mostly unseen and needs no dramatic embellishment. There is also a more personal obsession such an animal would create. Some people would dedicate their lives to it in ways only partly professional. Researchers, certainly. Trackers, documentarians, fishers turned observers, divers who never quite got over the first glimpse of a truly impossible silhouette beneath them. Every major animal has its devoted human orbit, but Megalodon would produce a particularly intense version because it offers not only study but pursuit. It is one thing to work on a species that is regularly visible in a known habitat. It is another to spend years trying to understand something rare, wide-ranging, and only briefly available to observation. That kind of work can become less like a job and more like a long negotiated relationship with uncertainty. Some of those people would become heroes in the public imagination. Marine biologists who helped prove the species existed, tagging experts who tracked the first adults, field researchers who kept their heads during dangerous encounters, the scientist who first identified the eDNA signature with enough confidence to risk saying so aloud, the fisher who preserved a tooth in proper context instead of selling it, the drone operator who captured the first unequivocal full-body footage. Human beings love attaching faces to difficult truths. It helps us feel that discovery belongs not only to institutions but to named lives. And then, inevitably, there would be the cult of seeing one. This may be the strangest and most predictable part of all. Once the shark was known, there would be people who simply had to witness it for themselves. Not in theory, not in a documentary, in person, offshore if necessary, at risk if required. The urge would not always be foolish. For some it would be scientific, for some spiritual, for some artistic. For some it would be no more mysterious than the same human impulse that sends people to watch volcanoes, storms, eclipses, and large wild animals on their own terms. We are pulled towards scale. We want to stand near what makes our ordinary sense of proportion fail. That longing would create a whole category of modern obsession. Expedition tourism, private submersible firms, offshore viewing platforms, chartered tracking vessels, specialised camera teams, enthusiasts studying movement reports with the focus of military analysts. Some of this would be valuable. Much of it would be chaotic. at least a few people would behave as though the privilege of wanting to see the animal somehow gave them rights over its space. Conservationists would spend a great deal of time repeating, with increasing fatigue, that fascination is not a permit. Still, the obsession would endure because the shark would keep touching something old in us. Not just fear, not just curiosity, something more stubborn. The need to know whether the world still contains realities large enough to interrupt our confidence. A living Megalodon would do that better than almost anything else. It would remind us that the planet is not fully translated into our preferred scale, that some truths are still bigger than our habits, and that the sea remains one of the few places where modern life can still be forced to admit it is not the central character. That may be why the animal would grow beyond all management plans and scientific papers into something like a permanent cultural companion. Not a friendly one, not a comfortable one, but a steady presence in the imagination. It would appear whenever people talked about risk, wildness, humility, old worlds, hidden things, or the cost of sharing a planet with creatures that do not care what we find reasonable. It would become shorthand for size and uncertainty. Parents would use it jokingly. Commentators would use it carelessly. Poets, reluctantly but inevitably, would use it better than most. The shark would no longer belong only to the ocean. It would belong to language. And yet, for all that noise, branding, argument and obsession, the real animal would still be out there living a life untouched by any of it. Feeding, migrating, avoiding injury, raising the odds of its young, moving through water that does not care about our headlines. That contrast would remain one of the most interesting parts of the whole story. The modern world would be busy turning Megalodon into symbol, story and controversy, while the shark itself continued doing what successful predators have always done, which is treat the world as material rather than meaning. And perhaps that is where the final stretch of this journey naturally leads, because once we've imagined the biology, the habitat, the hunger, the ecological ripple, the human response, and the cultural fixation, one thought remains underneath all the others. If a creature like this really did survive among us, then the world would be stranger, less settled, and in some ways healthier for refusing to be completely known. That is not a neat conclusion, and it should not be. A living Megalodon would not tidy anything. It would leave us with a planet that still makes room for giants, and with the uncomfortable, thrilling realization that making room for them would change us too. And perhaps that is the part worth sitting with for a little while, because after all the practical questions, all the maps, all the caution zones, all the science, policy, fear and fascination, what remains is something simpler. A world with a living Megalodon would be a world that had not finished surprising us. It would be a world in which the ocean still held enough scale, enough food, enough freedom, and enough mystery to support one of the largest predators ever to exist. That is a thrilling thought. It is also, if we are being honest, a slightly uncomfortable one, which is usually how the most interesting truths arrive. Over the course of this journey, we have imagined not only the shark itself, but the web of consequences that would follow it. We have looked at the animal as a real creature rather than a poster. We have asked how it might survive into the present, where it could live, what it would eat, how the rest of marine life would shift around it, and how quickly humans would begin behaving like humans in response, which is to say with a mixture of cleverness, panic, paperwork, and a deep emotional need to turn one biological fact into several arguments. That is our special talent. Give us a shark and we will produce a film, a policy dispute, a toy line, and a public moral crisis before lunch. But the larger point is not only that Megalodon would be impressive, it is that it would force us to notice what kind of planet we're actually living on. Modern life is very good at making the world feel finished. We have maps, satellites, databases, tracking systems, research fleets, and phones that can tell us the weather in 6 places at once, while simultaneously helping us ignore the tree outside the window. We have become used to the feeling that the planet is basically known now, perhaps not in every detail but in outline. Mountains are accounted for, deserts are familiar, forests are measured, even the ocean, which remains vast and difficult, is often spoken of as though it were simply waiting for the next device and the next survey budget to give up its final secrets in an orderly queue. A living Megalodon would break that mood immediately, not because we would know nothing. We would know quite a lot eventually. We would track it, study it, classify it, regulate around it, argue over it, and place it in documentaries with music that takes itself very seriously. But the discovery would remind us that mostly known is not the same as finished. The sea would feel large again in a way many people have forgotten how to feel. Not merely beautiful, not merely useful, large in authority, large in independence, large enough to carry a creature that did not ask permission to continue existing, while we were busy assuming the age of surprise was nearly over. And perhaps that is one reason the idea has such power over the imagination. It is not only about danger. People often say it is, but that is not quite true. If all we wanted was danger, there are easier ways to get it, and many of them involve much smaller animals with much worse attitudes. The real pull is that a surviving Megalodon would reintroduce scale into modern life. It would restore the feeling that some parts of the Earth still operate according to terms not set by us. The ocean would no longer be merely a place for transport, extraction, leisure and occasional concern. It would once again feel like a world with its own hierarchy, its own pressures, and its own large decisions unfolding below the surface regardless of what we happen to prefer. That would be inconvenient, of course. There is no use pretending otherwise. Coastlines would change, fisheries would change, some waters would become more complicated to use, certain routes would feel heavier, certain jobs would become more dangerous, some communities would carry burdens, others merely discuss from a safe distance. There would be real costs, real fear, and in some cases real grief. Coexisting with a giant predator is not a charming lifestyle accessory, it is a serious arrangement. The ocean has always demanded seriousness, but a living Megalodon would make that demand harder to ignore. Still, there is a difference between inconvenience and wrongness. Modern humans sometimes confuse the two. When nature becomes difficult near our plans, we tend to react as though a boundary has been violated, when very often the only boundary being disturbed is our own expectation that access should equal control. A world that still makes room for giants would not be a world designed around our convenience. In some ways, that would be the point. It would ask us to become more disciplined, more observant, and perhaps a little less entitled in the presence of places that are alive on a scale bigger than our habits. That kind of adjustment is not easy, but it is not impossible. We already do versions of it all over the planet. People share landscapes with bears, crocodiles, elephants, tigers, venomous snakes, wolves, and difficult weather. Farmers adapt, fishers adapt, coastal towns adapt. Children are taught different rules. Maps gain new meaning. Life goes on, not unchanged, but reorganized around a more honest relationship with the world. A Megalodon would simply require that same maturity offshore, in a realm where many of us have grown accustomed to assuming our presence is the main event. There is also something deeply useful in the thought that nature can still produce creatures too large, too old, and too consequential to fit neatly into our emotional categories. We prefer our animals to be legible, harmless enough to love openly, dangerous enough to admire from afar, intelligent enough to flatter us, or vulnerable enough to activate our concern. A Megalodon would be far less cooperative. It would be spectacular, yes. It would also be hungry, risky, ecologically necessary, and not especially interested in symbolizing anything for us. It would not be evil, it would not be noble, it would be a shark, which is often a more demanding fact than either villainy or virtue, and that may be why it would matter so much. A living Megalodon would make it harder to reduce the natural world into moral theatre. We would have to deal with the possibility that something can be dangerous and worth protecting at the same time. That is not a contradiction. It is just a sign that life is under no obligation to arrange itself around human comfort. Many of our biggest environmental problems begin when we cannot tolerate that truth. We either romanticize nature into harmlessness, or condemn it for failing to behave like scenery. A giant apex predator would not let us get away with either simplification for very long. It would also reshape how we think about extinction, survival, and time. There is something quietly sobering about realizing that an animal we place so firmly in the lost world might, under different circumstances, have remained alongside us all this time. It reminds us that the line between vanished and present is not always as emotionally stable as we make it. Species disappear. Species persist. Some endure in reduced numbers, hidden habitats, or unlikely refuges. A living megalodon would be an extreme example, but the principle behind it is broader. The world is full of survivals we only notice late, and absences we notice later still. Perhaps that is why the question feels bigger than the shark itself. What if Megalodon were still alive today? Is really also a question about what kind of present we imagine ourselves living in. Do we see the modern world as settled, catalogued, and basically complete, except for a few missing technical details? Or do we accept that even now, under satellites and shipping lanes and algorithms and neat little weather apps, the Earth may still contain realities large enough to unsettle the story we tell about being in charge? A megalodon says the second thing very clearly, not with words, thankfully, that would be unbearable, but with presence. And yet, for all that seriousness, there is room here too for a more ordinary feeling, which is delight. Quiet delight, perhaps, but real. There is something genuinely pleasing about imagining a planet that still has the capacity to embarrass our confidence. A planet that can still say, "You were not wrong about the science, exactly. You were just a bit too certain that you had counted everything important." That is not an insult. It is a correction, and in the long run, corrections like that are healthy. They make science sharper. They make public attention more alive. They remind us that curiosity is not a childish leftover to be outgrown, but one of the few sensible responses to living on an active and only partly obedient world. If a creature like Megalodon were really out there, then science would become not smaller but larger in response. We would listen more carefully, track more patiently, study migration more seriously, fund marine biology more generously, one hopes. We would learn more about whales, deep acoustics, offshore ecosystems, and the practical limits of our monitoring systems. We would be forced to improve not only our data, but our humility. That is often the hidden gift of a difficult discovery. It does not merely add a fact, it rearranges the scale on which we ask questions. At the same time, the discovery would ask something of us morally. Not sentimentality, not fear alone, something more adult than either. It would ask whether we can share a planet with a dangerous, extraordinary animal without immediately trying to erase it, exploit it, or turn it into an excuse for some unrelated human argument. That is a hard test. History suggests we do not always pass it on the first attempt, or the second, or sometimes at all. But it would still be the right test. A world that makes room for giants would not only be defined by whether the giant survives, it would also be defined by what our response to that survival reveals about us. Some people would never make peace with the idea, and that would be understandable. Not everyone wants their oceanic worldview corrected by a shark large enough to influence shipping policy. Some would become more cautious around the sea. Some would lose a certain easy trust in the horizon. Some coastal towns would carry a little more tension than before. But others would feel a different response, one harder to describe and yet equally real. Relief, almost. Relief that the world is not entirely reduced. Relief that there is still room in reality for something that exceeds our ordinary scale. Relief that the sea has not become merely a blue extension of our logistics. There is a curious comfort in that. Not comfort in danger. Comfort in reality remaining large. And perhaps that is the best place to leave the thought. Not with panic, not with triumph, not with some neat conclusion in which the shark becomes either a perfect villain or a perfect symbol of ecological wisdom. Real animals do not tidy stories for us. They complicate them. A living megalodon would complicate our oceans, our science, our laws, our industries, our fears, our films, our tourism brochures, our childhood imaginations, and our sense of what it means to inhabit a modern world. It would make some things harder. It would make some things better. It would certainly make things larger. So maybe the real answer to the question is not simply that the world would be more dangerous if Megalodon still lived. It would be more demanding, more honest, more alert, more aware of the old bargain between life and scale. The oceans would not become unusable, but they would become less casual, less decorative, less easily mistaken for something built for us first. We would still sail, swim, fish, study, surf, ferry, dive, and drift. We would still stand on cliffs and watch the water under changing weather. We would still listen to gulls, complain about sand in shoes, and forget where we left the towel. But beneath all that ordinary life, there would be a stronger understanding that the sea remains a place where other claims exist. And perhaps, if one is in the right mood for it, that is not only frightening, it is also rather good for the soul. Because somewhere beneath the surface, beyond the beaches and ferries and research grants and arguments on television, there would still be a creature carrying millions of years of uninterrupted predatory logic through dark water, not thinking about us, not trying to symbolize anything, not caring whether we found the whole matter inspiring or inconvenient, simply alive, simply continuing, simply proving, with every movement of that enormous body through the sea, that the earth is older, larger, and less tailored to our preferences than we often remember in the course of a normal day. And that is a useful thing to remember before sleep, I think. The world can feel very managed when evening comes. Screens glow, schedules tighten, notifications keep insisting they are urgent, rooms shrink around the day's leftovers. Our attention gets trained onto the small and immediate until life begins to feel made entirely of tasks, messages, updates, and indoor weather. Then along comes a question like this, and suddenly the mind is back out over deep water, considering whether the planet might still have room for a giant shark from another age. It is oddly calming in its own way, not because the shark is calm. It certainly is not calm in any meaningful human sense. But because the question restores proportion. It reminds you that the world is larger than your inbox, older than your errands, and under no pressure to become fully tidy for your convenience by tomorrow morning. So here you are now, a little farther along in the evening than when we began, sitting or lying in your own small corner of the world, while somewhere in imagination, and perhaps in some parallel version of reality, a massive shark moves through open water under moonlight or cloud or complete and indifferent darkness. And there is something almost companionable in that contrast. You on your side of the night, the sea on its side, each keeping time in a very different way. And wherever you're listening from tonight, whether the nearest ocean is just outside the window or many long roads away, I hope this journey has given your mind something good to do, other than chase its usual loops. If you found this thought experiment soothing, interesting, or simply a pleasant way to wind down with something large and improbable, I'd be very grateful if you liked the video, maybe subscribed, and shared this quiet little space with someone else who enjoys ending the day with science, questions, and the occasional completely unreasonable shark. For now, though, let the water settle a little. Let the maps close. Let the arguments, the drones, the hydrophones, the warning buoys, the policy debates, and the dramatic documentaries all drift off for the night. The ocean will still be there. The mystery will still be there. And somewhere in the idea of a world that still makes room for giants, there is a gentle reminder that not everything has to be explained all at once in order to be real, and not everything real has to be small enough to fit comfortably inside the mind before bed. Sleep well, wherever you are. And if you happen to dream of the sea tonight, perhaps let it stay wide, dark and full of life, just as it should be.